Hello everyone, welcome back to my channel again. Today I'm going to show you how to use very simple models from Hugging Face to complete different natural language processing tasks. So basically I'm going to use the free models hosted in Hugging Face, which supports the pipeline method for us to use the different models in different tasks. If you have seen my previous tests about Hugging Face models before, you might find the previous versions either oversimplified or the pipeline was not designed very well, or the workflow is not designed very well. But in this version, I'm going to simplify just to make sure that each part of the code can be run independently, so you can integrate them to your workflow or to your task more easily. Now let's go to the code. So first of all, we need to install the dependencies. The most important package is a transformer package, but of course if you want to add additional dependencies here, okay, you can integrate different packages to the workflow. But here I'm going to show you the very straightforward way to play with the models. So about text generation, you see I have chosen the distilled GPT-2 model and also this GPT-Neo 125 model. So it is very easy. We just load the pipeline and mention what is the task we are going to deal with and which model we're choosing. And we're going to set up the initial prompt. You can set a sentence, a paragraph, as long as you do not go over the context window. And you can generate this text by incorporating this pipeline to your initial prompt, mentioning about the max length of the output and also the number of return sequence. And you can see there are two results that I put here. Of course, because these models are very simplified, some of the answers are not making much sense, right? For example, this one, the first one is to write some fairy tale story, but you can see the second sentence does not go very well. The second one is about discovery of artificial intelligence. This is the AI community has been growing in numbers and sophistication. It makes a bit of sense, right? So you need to test to understand if the model is working well. But of course, it cannot match to the very complicated, very big models like the GPT-4 or the Claude models, right? Then if you want to further test, you can change the max output length. As you can see here, if you change it to a longer length, you're going to get more results. But some models may not give you what you want, like this one. Like the second model, it kind of repeats the information again and again, right? And this is about text generation. The pipeline is very straightforward. And of course, you can also fine-tune the model to with your own datasets. But please remember, because the simpler model, they have less parameters, so they cannot deal with very advanced task or to achieve very useful results like the big models. Now let's take a look at the text summarization. So the pipeline utilization is similar for all the different tasks. The important thing is that you need to make sure your understanding of the input and output are clear, so you can choose the different model. Like this one, we just put a paragraph of text here, and we're using different models to summarize it. Of course, about the summarized results, we need to have the max length, minimum length, these kind of parameters to control the output. And also there are some additional parameters like a do sample. Now I choose it to be false. Of course, you can also try the other options. Now let's see how it goes. So this text is about artificial intelligence, a description of the artificial intelligence, and mention the different aspects and description text. And you can see here we have the first one, from self-driving cars to virtual assistants like Siri and Alexa, AI is reshaping industries and daily life. Well, makes sense, right? Despite its potential, AI raises concerns, including ethical dilemmas like privacy invasion and biases in algorithm. And the second one does not seem to close the sentence in the end. but it makes some sense because the general description is okay. Okay, so these models are very small. This is the advantage. You can fit into your local machine very easily, or just run it in Colab, right? Without running out of the RAM, or necessarily incorporate a GPU to run it. But the results you need to distinguish and do different tests, and even you can incorporate different evaluation to see if the different results are matching your criteria. Let's check the entity identification part. So entity identification is also a very important task when you are dealing with language processing. So we are using this text paragraph as our base to analyze. As you can see here, there is BERT logic cased, fine-tuned. It's a very long name, right? If you want to see its detailed description, you can go to Hugging Face to check this model. And also the BERT base NER. These two models, and we can see it actually identified some of the entities, right? Like United Nations, but it actually separated these two words. Okay, but it marked them as international organization. Okay, and also AI is identified. Although for me, it's not an entity, but it has some criteria to mark it. But some things like this one does not make much sense, right? Let's see the next model. So in this model, we can see, okay, there is California. Yeah, it can be considered as entity, Google, and AI, or identified, like OpenAI, right? But it also separated token, which is not very clear to me, to be honest. But from this task, you can see that some of the entities are identified. But if the entity range is too broad for you, you can specify which kind of entity you want to identify, right? You can either fine-tune the model, or you can change some parameters during the pipeline and to make sure that the result is really useful for you. Okay, now let's go to the next topic. It's called mask token generation. As you can see here, I'm taking one sentence as my base of analysis, and I'm going to mask the tokens after the first token, and I'm going to ask the model to generate token after token. Because whenever you interact with these models, as you can see here, it will generate the text based on your requirements with a fixed max length. But here we want to see a progressive generation of the text. We need to do a manual engineering of the process. So as you can see here, the generate sequence is going to handle and interact with the model token after token. And eventually, we're going to generate the sequence and print out. As you can see, this is the result of the two models. And after each step, we're going to see one additional token. And in the end, we are going to see the whole sentence. And eventually, we can also compare the original sentence and the generated sentence. The original sentence is artificial intelligence is revolutionizing industries worldwide. The first one, artificial intelligence software development tools. The second one says artificial intelligence, Springer, and does not make much sense, right? One thing you need to bear in mind is that this kind of process simulation is outside of the model. So it is not in the same place as a model where it utilizes the attention mechanism or different mechanism to generate text, right? It is outside of the model. But it could be useful if you want to do some manipulation outside of the model. Then let's see this task about the mask token generation with longer non-mask part. Okay, so in this example, I'm just expanding the example to longer text sample. As you can see here, now I'm going to mask the second and the third sentence and keep the first sentence here. The basic structure does not change much, so we are going to see the results. As you can see, the first one starts predicting, but this word I'm not sure if it is Japanese or some other language, so I cannot recognize. Okay, eventually it's like a random results, right? Let's see the second one. Artificial intelligence is transforming industry worldwide, and the major research area in research are in effect the Human Genome Project worldwide. Well, at least this result is better than the previous one. although it does not make much sense, right? So this example is just to telling you when you do some alteration, you can see different results, okay? And see different manipulation of the natural language processing task. The next one we're going to see here is about text to voice or text to audio file. So the first test is about transforming these two sentences to audio file. We're going to use the speech T5 model and also the TDS model. Both are available in Hugging Face. But one thing you need to understand is for the speech generation task, you need to have a processor, model, and vocoder, 3 parts predefined before you go into the workflow, right? And here we're going to prepare the text, get the embedding, if any. If there's no embedding, we're just going to put a placeholder here. And going to use the model to generate the speech and write this file in the environment. And let's see the results. I'm not sure if you can hear it from my recording. In case you cannot hear it, you can try to run the code by yourself and check it. So basically, this is a very fuzzy sound. It's not very clear, okay? But in general, you can identify what it is saying about. Okay, so we have all these audio files generated. Okay, now let's go to the next task. It's about translation. About translation, one thing I want to say is in a broader range of translation tasks, you do not necessarily always need to use a variant model because some small models can already do a very good job. Like these models I chose here. One is Helsinki NLP, one is Facebook model. And let's see how it goes. So I'm translating this English sentence. Artificial intelligence is transforming industries worldwide. It translates to Italian. Intelligenza artificiale sta trasformando le industrie in tutto il mondo. So both translations are good and acceptable. Of course, you can increase the tokens of your text piece and try the different translation task. Here I want to mention these models again because I already shared with you in the previous videos. Here I want to emphasize that machine translation task has been going through many years of research. So if you have a very specific task that you want to do or not a very complicated translation task, you can use the small models. You just try it and see if that meets your demands in the use case. The last one I always like to test and play with is about sentiment analysis. So the first model is DistillBERT. I use this model for different natural language tasks. In the future, I'm going to share with you when I finished all the parts. Then also the BERT-based sentiment analysis model. It is going to give you a different result. Okay, and also we have some workflow here to actually analyze the sentences one by one. And also we are going to print out, for example, like the confidence score to let you know how confident is the model about the results. So like here, for the first model, we have 3 examples. The first one, it says it's positive. Yeah, I think it's right. The second one is negative. Both confidence is 100%. I think the model is very confident about results. Then the last one, acceptable but nothing extraordinary. I think it's neutral, right? But it tagged as negative. So we have 2 right answer, 1 wrong answer. Then we see the second model. The first one, it gave 5 stars, right? Positive, okay. 1 star is negative, okay. 3 star is neutral. I would say it's close, right? But the confidence score is not like the first model, very confident, because like the last one is not very sure. Is around 63% of the confidence. I think it is neutral. I agree. So here is also the summary. You can see for the first 2 examples, I think both of the models predicted the sentiment correctly. But the last one, 2 models have quite different results. So to do sentiment analysis, there are so many ways. You can also use a different technique from the very basic machine learning techniques, right? But if you use this kind of model if you have additional dataset, you can fine-tune the model, or you can test on your dataset to see if it works well. So I'm going to conclude here. I wish you like this video. If you like my channel, don't forget to subscribe. If you like my video, feel free to share it and give it a like. Leave any comments you like. I really enjoy discussing with you about any issues of the project and any ideas, any concepts about machine learning, AI, trading, coding, and so on. So I wish you a good weekend and see you next time. Bye bye. Hello everyone, welcome back to my channel again. Today I'm going to show you a very powerful tool. It is called Windsurf. It is a AI assisting program development tool which I find on the internet, and it's very interesting because it can help you to build up a program very fast and to help you manage the different programming files very quickly. So you can just check the name, it's called Windsurf, and after downloading and installing everything, you're going to see this interface. I have already opened one of the folder as Windsurf tutorial because I just want to show you how quick it can build up some applications and to see if we can ship it right away. I try not to disrupt the recording, and if I say something stupid, I feel sorry for that, so please ignore. But I want to show you that non-stopping programming with this tool. So on the right hand side, you can choose the different models. My preferred is Cloud 3.5 Sonnet. Okay, so we can just start coding by asking questions. It will generate different files, compare different files, right? It's very fast. So I have an idea because I already downloaded Ollama. I have already pulled the Llama 3.2 1B model in my local environment. So I think it would be cool to build a chatbot with such model. So I can interact with a very interesting UI and so on. About shipping, I think my understanding at this moment is to compose it to a Docker environment so that it can adapt to different operating systems, can be deployed. Okay, I'm not reaching to the point of commercially viable programs because that would involve a more complex problem set, and I'm not a professional data programming engineer. So what I'm saying now is I'm using this tool to build a program very fast and let it to make the program working and ship it via Docker. Okay, this is just my roadmap I described to you. So without further ado, let's go on with it. So first of all, I'm going to ask it what I'm going to build. Okay, so I will say build a chatbot app with elegant UI design, connecting to local Ollama, allow user to choose model from Ollama. I'm just going to start as simply as this. Let's see how it goes. Click enter. As you can see here, it just describes what it is going to do and starts to creating files step by step. First we have requirements, then the app.py, and it is running. One thing I want to mention before this is that whenever you use a prompt to interact with this tool, you always need to remember that you are still talking to a language model. So if you find that in the following steps that you need to refine your prompt. You need to limit some behaviors of the program. You always need to think back to the prompt engineering. Okay, so one of the experience I had before showing you this is that I asked it to improve the UI of my program or improve some of the functionality of my program. At some point, it will change the program, change the code in a way that I do not want. So in some way, you need to check some details to make sure that it follows your instruction correctly. Okay, so it suggests me to install requirements. Okay, please do so. And at this moment, I show you is a simplified version, right? I have not created any virtual environment and so on. But of course, you can add such instruction to do so. So you can see if it suggests you to run some command right away in the environment. I think it's a environment of the program. You're going to see the outputs here on the right hand side, not in PowerShell. Okay. Now it suggests you to run this application. I think I'll just accept all. Okay, accept all the modifications, because accepting all the modification, we're going to see this app.py, readme, and also requirements, right? So here, usually I would suggest you to reject it here, because my preference is to run it on the left hand side. So for example, like here, I click run. Let's see how it goes. Okay. Let me I think it is running. Yeah. So always you have two choices, right? You can run it in your terminal, or you run it in the program environment. It's optional. For me, I prefer to run it in my PowerShell environment. And if I have any question, I can copy paste the error code to the right hand side to debug and to improve the code. But it is totally optional. You can choose either way. Now let's see. Okay, finally we are here. Okay, so we have these yeah, I think I need to do this one. Yeah, because Streamlit I did before. This is correct command. Let's try. Yeah, it's kind of slow. While we're waiting, okay, now it comes out. Let's see it. Okay, it is based on the Streamlit framework, and I can also see the available model is correct. Okay, and there are also some suggestions here about how to use the model, right? And we can type in our message here. I would say, what is LLM? Okay, click send. So it's running. AI is thinking. Let's hope it will give us response. Okay. So we have this error. Let's come back. Of course, this error, I think, is also shown in this environment. Let's come back. Okay, Control L. Okay, the environment kind of disappeared. So let's see if we can restart quickly. Insert. I think it's loading. So while it's loading, let's take a quick look at the code. Right. So first of all, it utilizes the Streamlit. It will follow the Streamlit design and documentation, I think. So you can see the Streamlit set page configuration, set markdown, everything looks good. And it handles the request to Olama. Okay. All looks okay. But now the problem is that it cannot show the results correctly, right? So we just copy the error here. And no, I cannot directly start the chart because it will be a new one. The right way is to find the chat history referring the current application. Okay, so I'm going to click this workflow. Yeah, we're here. And I'm going to type in this error. It will think and will give you suggestions to modify the code. And you can see here, it will show you, I think whenever I check the modification, I will see the most important statistics shown here. How many insertions, how many deletions. This is quite important because sometimes if I already have a prototype of my program which is almost ready to ship or ready to deploy, and I ask it to further improve, you're going to see, for example, 100 deletion and only 2 insertion. You should be careful because usually that means that it unintentionally simplify your application or your code. Okay, I think unintentionally because it tries to improve the app based on your instruction, your prompt, but it also has some side effect. Okay, always pay attention to this. So as you can see here, I think the modification looks good because there's not much of the deletion. I think at least I can just to make it faster, I can just try, and I can also roll back. There's no problem because it only is 2 or 3 lines. This one I'm going to reject because I'm not going to run it. Okay, I'm going to string wait run app.py. Okay, let's try that. Good. Okay, let's close that one. Okay, what is LLM? Let's try again. AI is thinking. No, it's still this issue. Okay, I'm going to say unable to get answer. Check thoroughly and improve. Okay, every prompt you can customize as you wish. But the problem is you need to pinpoint to the problem, because now, without looking into the detailed code, I just wanted to figure out a way to pinpoint the issue and then resolve it right away. So let's see if it can do it in, I don't know, 2 to 3 iterations. So the more complicated your program is, the more iteration you will need to do. Okay, because it is just like writing the code with GPT-01 or GPT-4o. Oftentimes, I find that when you program a very complicated design of the app, you will need a lot of time to carefully think of how to prompt the model to help you code. And of course, you need to do a lot of tests and debug. So here, let's accept the modification again, and let's try. Just going to close it, and let's run it again. It's a bit slow. Let's wait for a while. For this windsurf tool, you can see that after each round of conversation, you can see it describes everything clearly. I think this is a very good point. Okay, so let's try it. Streamlit run app.py. Yeah, here we are. Let's try. What is area? Still no. Okay. So let's try again to see if the tool can help us with this. Let's see. It says line 1.4. Let's see the previous one. 5. I think the error is similar. Session state, user input. Now it's input. Let's see. Proper session state initialization. Okay, callback. Improve the input handling. Okay, let's accept. Okay. Sorry. We need to streamlit run app.py. Okay, okay. We have extra data line 2 column 1 char 127. Not sure what did not work. Let's try. Yeah, one more thing is that when you develop the app, for example, now the model directly suggests me to use this package of Streamlit. In another case, it would suggest me to hard code the HTML structure to show the UI of talking with large language model. But if you already have something in mind, it's better to specify. Okay, like in this time, I do not specify. But if you already have some packages in mind, you have some tools in mind, it's better to specify. So I think the development process could speed up. Okay. Now let's try it again. Unit run app.py. Okay, here we are. What is large language model? Running. Okay, we have additional error. Not instantiated. Okay, let's see here. Okay, let's copy this one. Copy this code, this error message directly from our PowerShell. Let's see if it can debug. Now we're in, I think, 4th or 5th round of iteration. I have not checked any of the code alongside with Streamlit documentation or some examples. Let's see here. It actually deletes more code than adding code. Let's try. Like here, I think add UI improvement. This is not 100% necessary. But if you do not want to see this, what you can do? When you prompt the system, you just add one line. It's like, do not do extremely, or we can say, do modification only if it is extremely necessary. So in that way, it will not touch anything that you did not specify in your prompt. Okay. So let's try again. Now we have the web page. What is LLM? Okay, so there are some attributes not inside of the package. Let's try. I'm not sure. My feeling is that this modification will not change anything. Let's try again. Right, this is another way that I do not input the prompt in the PowerShell. I can just go here and refresh. Let's try it. Okay, I think it is working now, right? The reason I'm telling you this is that for my previous test, the Llama 3.1, 3.2 1B model also gave me a similar response. It's called Llama, right? Only if I specify it to large language model. In this way, it will answer the question referring to large language model. Let's see it. Yeah, here we go. You have everything laid out. I think one good thing about Streamlit is that you do not need to spend a lot of time to think about the UI design, because the UI design is not so easy, right? You might understand what you want, how you want the textual result to lay out beautifully, but to actually make the layout organized, flexible, I mean, using tools like Streamlit could be extremely useful. Let's see if the coding will be rendered, right? Additional code generated by the large language model. Let's see, code to display APL price plot. Okay, let's see. Okay, here we have the code. And you see, it directly render this part as code. So you can copy it. If you look at it closely, from here, from the starting of the code to the end of the code, is light gray. You need to look really carefully because the boundary is not very clear. Okay, and it will also mention you need to install the dependencies, right? So at this moment, I think we can say after 5 or 6 iterations, okay, 6 or 7 iterations, without interrupting the process, without manually inspect the code, we get a functionable local chatbot, okay, hosted locally. But of course, without Llama, you need to install Llama and pull the model first. You can try any model in your local environment. But the thing you need to consider is that, first of all, if you have the GPU resource or the compute resource locally to help you to host larger model, right? If a small model like 3.21b model, I think is okay. So in the future, you can also use this tool to further improve, right? For example, like if you want during the conversation, you can run the code just like ChatGPT, right? When you ask ChatGPT to perform a task, it could run the code, write the code, and then run the code, and then you are going to see the result. For this, you can also try with the tool to see if you can improve with Streamlit or other package, or just hard code everything from ground zero. I wish you like this video. I do not edit any of it. And if you want to follow every step, if you have any question, feel free to let me know. Okay, I do wish you can follow it step by step, try it by yourself, create something magical or different from my version. Okay, if you have any question, just leave a comment. Don't forget to subscribe, and see you next time. Bye bye. Hello everyone, welcome back to my channel again. So if you saw my last video about Windsurf, quick programming in 30 minutes for a local chatbot, you know that Windsurf is a very powerful tool that can help you quickly program a application, a chatbot in local environment. Now we are going to follow up the same project, and to complete another part, I want to compose it to the Docker environment so we can easily use such application in different platforms. So let's try if this Windsurf programming assistant can help us with that. So the first thing we need to do is, of course, we need to have the Docker installed and also up and running. So we check we have the Docker. Yeah, now we have it. Let's just wait. Okay, now it is up and running. Yeah, and let's go here and see. Okay, now let's do Docker compose up. Yeah, so now it is going to create necessary files, especially the YML file for the Docker Composer. And you see most of the coding now is only adding entries, deleting nothing, because we are creating multiple files. And you can see on the left hand side, different files are getting created. And let's wait. Okay, so it actually edited some of the code in app.py. It used the Ollama host environment variable. I suppose it is very necessary to compose the Docker file. Let's run this command. And sorry, I should click accept all first. Okay, let's see. Okay, I think there are some errors. Yeah. Let's see on the Docker side. Yeah, we do not see it. These are some of the previous version of the application that I tried to build, but it was not so successful. I'm going to delete. And okay, let's try again. Highlighting some of the errors here. Copy and share here. Okay, so this time I'm going to run it in PowerShell. Let's see if we can finish composing. Okay. I got an error. Let me see. Okay. I should do this. Let's see. Okay, it's working. Let's see. Okay, now is the pip requirements. Okay. There is an error message. Conflict. Container name Ollama is already in use by container. I think is this one. Yeah, because I used Ollama here. Let's try to delete it. I think this is what we have just composed this image. Let's run it. Okay. No, I think there's something wrong. Let's see. There is no container ID. Let me check. This is also my first time to compose a program to Docker, so I have no idea how it works. Alright, let me try to ask. After running image, no container ID, no image tag, how to run it? Yeah, I'm going to reject it. Reject it. Okay, let it check. It's checking. Okay. So it quickly checks the images currently in here. Clean up existing containers and images to start fresh. Yeah, I think we can do that. Okay, so I believe our images will disappear or not. Remove any running container. Okay. Yeah, this is Perplexica, a package I tried before but was not so successful. Okay. You see, this tool is very useful because it also can interact with Docker, understand everything. Okay. Inserting terminal. Okay. No. Let me try. No such container. Okay. Hello. Now let's try again. Okay, just to avoid confusion, I think I should delete the things that I'm not using and create confusion. Okay, if it's running, I cannot. Let me try to stop everything. Okay, stop also this one. No. Front end using. Let me see. No. Llama. Okay. Now let's try. Should we redo compose? Just 1 second. Okay, let's try it. Okay, Llama. Okay, Delete containers, delete our useful ones. Okay, I think we also delete this one because we're going to redo. Let's redo compose up. You can see here there is a status. This is running the composing step. Error response. Let me try again. So in the okay, let me try. Let's just follow its suggestions to do some modification on Docker and redo the compose up. Okay, sure. Here I'm going to reject, but here in PowerShell let's redo. Okay, so still the same problem. Yeah, let's see. I think alternatively we can change to another port. Stop it, it's too slow. Can we change to another port? It's not responding. Okay, let's just restart the program. All right. Can we change to another port? Yeah, let's do a 502. Good. Let's see. because I did not accept the first then run it, so you can see here the URL is still 8501. So I'm going to stop here and redo here. Okay. So take a look at here. Yes, we have it. Stopped. Okay. Let's try to start again. Okay. Okay, you see now? There is a problem. Let me try. What's this one? Yeah, this is just a llama. Here we are. We can, but strangely, let me see here. Yeah, you do not see the port here, but here we can open it. Okay, so let's ask this question. After running 8502. Okay, let's see how it goes. Okay. I might. Okay, so the problem might be that it is not actually calling the Ollama installed in my local environment. It is calling an Ollama installed in Docker environment. Okay, so in that case, we need to have. Okay, there are some suggestions of changing the code. Let me check if it is really necessary. I do not think it's 100% necessary. See, selected models, everything is the same. Alright, let's follow its suggestion and then compose up again. Okay, Docker compose up, reject here or here. Okay. I'm not sure. Let me check. Okay, now it gives me 3.21B model. They actually allow me to pull the model first. Yeah, this is new to me, but it seems okay and logical. So I can pull any model I want. This model is not so small. It's if I remember correctly, is around 1 to 2 gigabytes. It will take some time, but you see here we already have a Tiny Llama latest model available. Yeah, we can see here. It is actually downloading. Yeah, but the thing is that I think it's in Docker environment, not in our local environment. Okay, that's cool. Yeah, now we have a Tiny Llama and a Llama 3.21B. Okay, what is LLM? Let's ask some questions to understand. if it is working. Okay, perfect. So now it is working. How does embedding models work? Consider LLM workflow. Yeah, does not make much sense, but let's ask. Okay, so during the iteration, as you can see, it actually changes some of the code. You can see the UI, some of the layout, some of the information shown here are changed. This is new about pooling a model, but it could be very useful to allow you to choose different options from Olama. But of course, you need to consider if you already prepare it in advance, you could go to the chat faster. If you pull it every time you run model, run the program, it may not be very efficient, right? Okay, so my second question does not seem to have a response. Maybe it will be much longer, I suppose. Because you see my PC is not a very new machine and you can see the fans are working. Okay, good. Embedding models, pre-trained, language model or transformer-based models. Okay. Okay, so without checking any more details, I think it's working. Okay, so during this Docker composing step, okay, my wish is that we can put the program as an image inside of Docker environment. So whenever we test it, it could be in a safe place, right? It does not interfere with other components in your operating system. And during the iteration using the Windsurf coding assistant, it actually offered me additional option, which is a surprise. Change some of the layout of the UI, a surprise, which I should avoid during my prompting process. And eventually it works in Docker environment. Right. And you can see the URL is A502 because I wanted to avoid, right? Avoid the conflict as you saw before. Yeah, I think this is about it. And let's come back to Docker environment and check it again. So we have our image here. We have, okay, the Olama and also the Olama chat UI in the name. Okay. I think, let me check. Olama chat UI is not the image I created. It's not related to what I created. I think it's only this one, right? It's Windsurf tutorial of Llama data. Is this one. And container is this one. When I come inside and I have my chat UI here. To be honest, I have not yet 100% figured out how the Docker environment is set up, but at least at this moment it works. So about the Docker, if I find something new or very interesting and useful for your program development, I'm going to share with you in the future. But at this moment, I already achieved the goal that I set in the previous video. So just a total summary, I used the Windsurf programming assistant to build an app in 30 minutes. And after also similar duration, I think, I did some iterations considering composing up this program to Docker environment. Eventually, I got success and I got additional functionality like a pooled model and so on. And I think I'm going to also share this part in my GitHub repository, so you can take it as a reference. Okay. I wish you like I wish you like this. I wish you like this video, and still, this video will not be edited because I want you to be able to follow every step. Because to complete the whole workflow is not always like a 10 minutes video, right? When I run it, I may meet different problems. So if you see similar problems, I wish it will be useful for you. Okay. If you like my video, feel free to like it, leave a comment, and if you have any question, feel free to reach me out. And do not forget to subscribe, and see you next time. Bye bye.
Hey everyone, welcome back for another deep dive. We've been spending a lot of time talking about large language models and all the incredible things they can do.
Yeah, it's a really exciting field.
For sure. But this time, we're taking things up a notch.
Oh.
Yeah, we're going to go beyond just simple chatbot stuff. We're going to see how LLMs can actually use outside information.
Like how to really think.
Exactly. It's like teaching a computer to not just talk, but to actually learn from the world around it. So we're diving into this research paper titled Retrieval Augmented Generation, RAG and Beyond.
Oh, wow. I've heard of that one.
You're familiar with it?
I've skimmed it. Looks dense.
Oh, yeah. It's pretty intense. But that's why we're here, to break it down.
Make it digestible.
Right, because this stuff has huge implications. Imagine LLMs that can analyze financial data or help doctors diagnose illnesses, or even,
Assist lawyers?
Yeah. All while staying up to date with the latest info. This isn't just about having a super smart chatbot. It's about creating powerful tools.
For all sorts of fields.
Exactly. But before we get too carried away, let's break down what this retrieval augmented generation actually means.
Okay, so think about it this way. Traditional LLMs, they're trained on massive amounts of data.
Right. Huge data sets.
Yeah, which is great for general knowledge. But that information, it can get outdated pretty quickly. And sometimes, get this, LLMs can even hallucinate, like make up information.
Hallucinate? Yeah.
They just start spitting out stuff that sounds plausible, but is totally made up.
Whoa. That's a little unsettling.
Definitely. Can you imagine relying on an LLM for medical advice and it starts inventing symptoms?
That's a scary thought.
Yeah. That's where RAG comes in. It basically gives LLMs access to external, up-to-date information. It's like giving them a direct line to...
A world's knowledge.
Precisely.
So our RAG is like a super-powered research assistant for the LLM, making sure it's working with the most current information. I like it. But the paper doesn't stop there, does it? It actually categorizes the ways LLMs use this external data.
Oh, yeah, it gets way more granular.
Yeah. Into these 4 levels of queries.
4 levels. And understanding those levels is key to understanding how complex this stuff really is.
Right, because it's not just about finding information, it's about...
knowing how to use it.
Exactly. Okay, so level 1. Explicit fact queries. This sounds like the simplest type.
It is. It's the most straightforward. Think of it like asking, where were the 2024 Summer Olympics held? The LLM can just pull that answer straight from a database.
Like a supercharged Google search.
Basically.
Got it. Simple and efficient. Okay, now level 2 is the implicit fact queries. These seem a bit trickier.
A little bit, yeah. Here, the LLM needs to put together different pieces of information to get to the answer.
Okay.
For example, let's say you ask, what is the majority party in the country where Canberra is located?
Okay.
Well, the LLM needs to know that Canberra is in Australia and then figure out what the political landscape is in Australia. It's like...
2-part puzzle.
Yeah, exactly.
Okay, so we're building on the complexity here with each level. So level 3. Interpretable rationale queries. This is where things start to get really interesting, right?
Absolutely. Now we're talking about not just facts, but also understanding the why behind those facts.
The reasoning.
Exactly. Applying rules and logic to solve real-world problems.
Okay, so give me an example. Like, paint me a picture.
Sure. Imagine you're asking a medical LLM. You say, how should I diagnose and treat chest pain?
All right.
The LLM, it can't just regurgitate symptoms. It needs to understand medical guidelines, best practices. It's got to think.
Like a doctor.
Yeah. More than just a medical encyclopedia.
Wow. Okay, so that's pretty impressive. And then we have level 4. Hidden rationale queries. This sounds like the ultimate challenge.
It is. This is where it gets really complex.
It's really complex.
Now we're talking about cases where the reasoning behind a decision is not explicitly stated anywhere.
It's hidden.
Yeah. The LLM has to infer the reasoning from the data itself. like a detective.
Piecing together clues.
Yeah. Exactly.
Yeah.
So for example, let's say you asked an LLM to analyze a bunch of financial reports and predict a company's future. It would need to sift through tons of data, look for patterns without any clear instructions on what to look for.
And make a judgment call.
Yes. And the rationale for that prediction, it might not be written down anywhere. It has to learn to connect the dots. Exactly.
Yep.
Like a human expert.
This is mind-blowing stuff, but it's also a little daunting. I mean, even with RAG bringing in all this external data, how do you teach an LLM to actually process and understand it all?
Yeah.
Especially when you think about all the different formats information comes in.
Yeah, that's a huge challenge. And that's what we're going to dive into next. There's some really clever solutions being developed to tackle that problem.
Okay, so my brain is officially buzzing. We've got these 4 levels of queries, but how do you actually teach an LLM to deal with all this external data?
Right, because it's one thing to give an LLM access to information.
It's another to make sure it can actually use it.
Exactly. It's like giving someone all the ingredients for a fancy meal, but no recipe.
Or cooking skills.
Right. You need to teach the LLM how to actually work with what it's given.
So what are some of the biggest challenges researchers are facing with this?
Well, one of the biggest hurdles is just the variety of data formats out there.
Oh, yeah, it's not all neat and tidy.
No. No, it's not all nicely organized text in a database. We're talking about research papers, news articles, social media posts.
A whole jumbled mess of info.
Yeah, and a lot of it isn't even text.
Right. There are images and charts and
graphs, videos. How do you teach an LLM to understand a pie chart?
Or a photograph.
Exactly. That's the challenge of multimodal data. It's like trying to teach someone to read in multiple languages at the same time.
Wow. Yeah, that's a good analogy.
One approach is to try to convert everything into text.
Like translate it?
Yeah, kind of.
Yeah.
So imagine turning a chart into a series of sentences.
Describing what it shows.
Right. But then you have things that are just too complex to easily summarize, like a scientific diagram.
Or a video clip.
Yeah. So for those cases, researchers are using something called multimodal embeddings.
Embeddings?
Yeah, think of it like creating a universal language that the LLM can understand.
Like Esperanto for data.
Exactly. Yeah. It lets the LLM process and compare different types of information, even if they weren't originally in the same format.
So you're either translating it or finding a way to represent it in a way that the LLM already understands. Clever. But even once you've dealt with the formatting issue, there's still the problem of actually finding the right information, right? It's like looking for a needle in a haystack.
A very big haystack.
Yeah. So how do you make sure the LLM doesn't get lost in all that data?
Well, one approach is to use dense retrieval.
Dense retrieval.
And uses machine learning to understand the meaning behind your query.
Not just the keywords.
Right. So instead of just looking for a document that contains the exact phrase Summer Olympics 2024, it might understand that you're actually interested in
the location,
the medal winners,
the controversies.
Yeah. It allows LLMs to understand the nuance. Exactly.
Yeah.
Which is especially important when we start talking about those higher level queries.
Where the LLM actually needs to reason.
Yes. It needs to connect the dots.
Right. Like it's the difference between knowing a bunch of facts and actually being able to use those facts
to solve more back.
To make an argument, to think critically.
Exactly. And to handle those more complex queries, researchers are developing these special techniques to guide the LLM's reasoning process.
Okay, now I'm really intrigued. What kind of techniques are we talking about?
Well, one approach is called prompt engineering.
Prompt engineering?
It's all about asking the right questions.
Okay.
Instead of just asking the LLM for an answer, you carefully craft a set of instructions or a series of questions that give it context.
Like a roadmap.
Yes, a roadmap. Instead of just asking a medical LLM, what's the diagnosis?
You might give it some background information about the patient.
Their symptoms.
Medical history.
And maybe even point it to relevant sections in a textbook.
So you're basically giving it a crash course.
Exactly. And by structuring the input in this way, you can help the LLM focus on the right information.
And use its reasoning powers more effectively.
Right. Another cool technique is called chain of thought prompting, or COAT.
Chain of thought.
It's a way to encourage the LLM to think step by step.
Oh, so you can see how it's getting to the answer.
Exactly. It makes the reasoning process more transparent.
Which I like. It's always a little unnerving when you don't know
how the machine is thinking.
Yeah, exactly. Black box AI is kind of creepy. So with co-prompting, it's like you're asking the LLM to
show its work.
Like a student solving a math problem.
Yes. Instead of just giving you the final answer, it explains how it got there.
So for our chest pain example, the LLM might say something like, the patient is experiencing chest pain, shortness of breath, and nausea. These symptoms, combined with their age and medical history, suggest a possible heart attack. We should consult the section on myocardial infarction in the cardiology textbook.
Exactly. And by having it articulate its thought process like that, we can gain insights into...
Where its logic is sound.
Yes. And we can also use that to refine our prompts and improve the LLM's performance over time.
It's like having the LLM teach us how to teach it better.
Exactly.
But I imagine crafting these prompts and chains of thought, it can be pretty time-consuming.
It can be. But the good news is that researchers are developing tools to help automate this process.
Oh, like using machine learning to optimize the prompt?
Yes, or even generate CoT prompts automatically.
So it's like having a personal assistant.
For your AI assistant.
Ow, that's efficiency. But even with all these tools, how do you teach an LLM to handle those really complex hidden rationale queries where the why isn't clearly stated anywhere? That seems like a whole other level.
Yeah, right. Those are the toughest ones.
Yeah.
And they require a whole different set of approaches. It's almost like teaching an LLM to develop intuition.
To pick up on patterns.
To make judgments based on incomplete information, like we humans do all the time.
All right, so we've covered a ton of ground. Different levels of queries, the challenges of processing all this external data, and even some pretty cool techniques for guiding an LLM's reasoning.
There's a lot to take in.
It is. But now let's get to the heart of it. How is all this external data actually integrated into an LLM? How do you make it all work together?
Well, the paper outlines 3 main methods: context, small model, and fine-tuning.
3 methods. Okay.
Each one has its own strengths and weaknesses.
So it's like choosing the right tool for the job.
Exactly. So let's start with the simplest one, context.
Context. Okay.
The basic idea here is that you're giving the LLM a cheat sheet.
A cheat sheet, yeah.
You identify the key data snippets from those external sources, and those snippets become part of the input to the LLM.
Along with the query.
Right. So it's like saying, hey, LLM, here's everything you need to know to solve this problem. Go nuts.
Straightforward enough. What are the downsides?
Well, the main limitation is that LLMs have a finite context window. There's a limit to how much information they can process at once.
Like trying to cram too much stuff into a suitcase.
Exactly. So this approach, it works great when you can narrow down the knowledge to a manageable chunk.
But not so much for really complex queries that need tons of background.
Right. For those situations, you might want to go with the small model method.
Small model. So we're training a mini-me version of the main LLM.
Kind of. You train a smaller model, but it's specialized.
Okay.
And this small model, it becomes like a subject matter expert.
Ah, I see.
And it can then guide the larger LLM.
So it's like a team of specialists working together.
Yeah, each with their own area of expertise. And this way, you can handle much larger data sets and more complex reasoning.
Because you're dividing and conquering the information overload?
Exactly.
But I'm guessing even training a small model still takes a lot of
time and resources. Yeah, definitely. It's a trade-off.
Right. Okay. And then we have the fine-tuning method.
This is the most intensive one.
So this is where we're really getting into the nitty-gritty.
Yes. With fine-tuning, you're actually further training the LLM itself on the specific external data you want it to work with.
So we're not using a separate model anymore.
Right. It's like taking a general doctor and sending them to become a specialist.
So you're upgrading the main LLM with specialized knowledge.
Precisely. And this can lead to the highest performance because the LLM becomes deeply integrated with that data.
But couldn't that introduce bias if you're only training it on a specific data set?
That's a really good point. Fine-tuning requires a lot of care. You have to make sure the training data is balanced, representative.
And that you're not making the LLM too specialized?
Yes. You don't want it to only be good at one specific thing.
Right. Like if all you have is a hammer, everything looks like a nail.
So it sounds like choosing the right integration method is a delicate balancing act.
It is. You have to think about the complexity of the task, the resources you have available, the level of performance you need.
And the risks involved.
Exactly. It's amazing to see how much progress has been made in this field, but it also makes you realize the ethical considerations that come along with it.
Oh, absolutely. As these LLMs become more powerful, as we integrate them more with the real world, we have to be really thoughtful about the implications.
Make sure we're using this technology for good.
Exactly.
Well, this has been another incredible deep dive. We've gone from understanding how LLMs can use external data to think, to exploring the nuts and bolts of how that integration actually works.
And we've only just scratched the surface.
I know. It's mind-boggling to think about what the future holds for this technology. Thanks for joining us, everyone. We'll be back next week with another deep dive into the world of AI. Until then, keep learning and keep exploring.
Hello everyone, welcome back to my channel again. Today I'm going to show you this very powerful tool. It's called Windsurf, presented by Codian. This is a Agentic IDE, which in a simple way to describe it is that it can automate all the programming procedures and provide you with an additional boost of productivity. So I'm going to show you now is how to use it to maintain your GitHub repository and to gain additional efficiency. So let's get on with it. Before we start, I created this GitHub account. It is fresh, it has nothing in it. Before you use it to interact with your GitHub account and also the repository, you need to set up the credential. Like I said, change the associated Git account to email address and so on. And also mention my username. It will change the configuration, so it will be ready to go. So the first command I'm going to try to use is this one, which I stopped some time ago, just a few minutes ago. I'm going to ask, can you create a repo called chatbot? It will process my prompt, and with the model is called Claude 3.5 Sonnet. Let's see what it says. Okay, it will help me to create this directory. And let's accept. Okay, it's not okay, so it changes to another prompt. Yes, let's see. Okay, now commit to repo. Yeah, so you see it will create a README file and commit to my GitHub account. Let's see if it works. Okay, so basically every time when you accept its suggestion to run a specific command with GitHub, it will show also the results and a short summary, right? One suggestion is that you already see that I click the accept all changes after it shows all the information. My suggestion is that you always click accept the changes, then run the different command or accept the running of that command. I think it will be more logical. Okay, so anyway, let's refresh the page. Let's see if we already have our repository. Okay, let's see. Okay, I do not see. Sorry, go to the wrong place. No, I do not have anything yet. Let me ask. I do not see new repo in my account. Okay, so I guess this step I cannot automate, so I'm going to make it here. I'm going to say it's called chatbot public. Okay. Okay, now I think it is created. So I'm going to say now I have chatbot repo created in GitHub. Please commit the change. because I think it created a README file. Let's go to make it in our repository. And still it will show step-by-step instructions and also summary. Let's refresh and see if we already have such file. Okay. There is an authentication issue. I need the authentication. Let me try to use authentication code. I think I'm going to get here. And let me check. I should. Okay. Setting developer setting. Target setting. Developer setting. Generate new token, personal access token, classic token, generate a new token, classic. Okay, I'm going to allow all the functionality. And we can generate a token for demonstration purpose. I think 1 would be enough. Generate a token. Okay, node test. Let's try again. Okay, now I have this token. After the test, I'm going to delete it. Okay. Now let's try again. I think we'll be fine at this moment. Yeah, push successful. So let's refresh. Let's go to our repo, to the chatbot. Yeah, now we have this empty file, okay, written by the program, the IDE, and we get it. Okay, so now let's create a very simple program. Okay, so let's create a simple program using stringlet to chat with local LLM. Make sure user can choose available model. It should not be so complicated, right? Now it is going to create first of all the requirements dependencies, and we are going to see some generation here. I want to mention one thing for you. Because I'm creating a very simple workflow, a simple application, I do not need to consider a lot of guardrail about my prompt. But if you develop a very complicated structure, you always need to be more careful about checking the proposed changes, and if you want to proceed or not, and which kind of file you allow it to change or you do not allow it to change. Okay, so I'm going to allow it just to speed up. I think it has already finished the programming. and push the file. Okay, it has created the chat inference application, made two files, updated the readme. So now we can run it in local environment. Also, let's check in our GitHub. Okay, you see, we already have a very comprehensive README file about this application. It says it will chat with local Ollama, select the available model, and so on. Yeah, all looks good. And how to clone the repo, install dependencies, and run it with this command. Okay, so let's try in our environment. As I said, always, if you see the highlight, accept or reject, better to check it before you run the command here. And whenever some part of the code or the file is highlighted, which means that you have the choice to accept or reject the proposed change. Okay, so let's try this application. Unable to process. Let me see. It says fatal error. Okay, let's see, maybe we need to, okay, I'll ask it, install dependencies and run the app. Okay, so in this way, I do not need to go to PowerShell to insert different commands. It will run it for me. First of all, installing the dependencies. Okay, we will also show you this output, and it's also nicely structured, so it does not occupy the whole window. It's very nicely designed, and you are also going to see the status. It is running. Okay, I think finished. Now we're going to run. Let's run this application. Yeah, now we have this app shown in our browser. Yes, this is the model available in my environment. I'm going to ask how to learn coding. Yeah. Well, and you can see there these small signs as the user, as the bot, are very nicely chosen and put here. And we can see this is the result we get from the local large language model inferencing. So it looks good. The app is working, right? So, which means that we, first of all, we manually created this repo. We ask it to generate a sample README file, and I work on the application, let it create it, test, and push it to our GitHub, and we test it. It is okay. So for now, I think we already closed a small loop of the work. So at this moment, you could further change the README file. For example, let me say that please make the README file more engaging. So it will update it, give some suggestions, and you can accept the change and push commit. Yeah, it actually did a lot of changes. I'll accept all. Accept. Again, if you want to be more prudent, you should check every change. Okay. This is only for demonstration purpose. I'm going to go as fast as I can. Now, you see it adds some emoji. I think the display is more user-friendly. Let's refresh. Okay, it's very nice. Now you can see also the Python package requirements. Streamly version, Ollama, and you'll see there are some features and quick start. Okay, let's try this Ollama link. It's working. Yeah, very good. Because sometimes if you do not specify the URL or the link that you want to put here, sometimes it will be a random link. Sometimes it does not work. So everything looks perfect, and also some pro tips. Okay. Yeah, it also mentions that you can pull some models which are, I think, are most cited models in Ollama. I'm not sure. And also, it mentions you can contribute to the project, and this is available under MIT license. Let me see if it has a license. No. So let's see. Add MIT license. Okay. So it will generate the license file, and we can put it in our repo. You see, this is an agentic workflow in code editing, execution of commands, and now also interaction with GitHub. Everything is agentic workflow, right? So you can see it's a step-by-step, it's well organized, and always ask a user to give the final decision. This is super important because imagine if everything now is automatic, without a guardrail, without human intervention. I think the agentic workflow can do everything or anything. Let's refresh page. Yes, we have the license. License file is MIT. Okay, good. And also mention the user and the year. Okay, looks good. Okay, so we finished the first task I want to share with you. Build an app, complete all the documentation, push to the repository. And now, because as you saw, I cannot create a repo directly from the command, so I'm going to create another one. I'm going to create with the same username. I think .github.io. I think this is going to be the page where I create my personal web page, right? So I say I created a repo as please design my personal web page. Be creative and mention multiple links. If not available, use placeholder. And we click enter. Okay, it starts to create personal website. Let's accept. Let's just take a look into the detail here. Okay. First of all, it clones the repository. Okay, it is working. Index HTML. I think we should be getting ready because this web page will be used to view our personal page. At this moment, it is not available, but soon it will. Okay, the file is created. Let's take a quick look. Okay, it is all designed for this web page. Okay, by the sheer amount, the sheer count of the lines here, I think it is not a bad start. Let's come back and see here. Okay, it will also create a CSS file with a modern, clean design. Okay, sounds good. Let's see. Okay. This is very, very comprehensive, right? So how much time do you spend to write 300 lines of code to make the UI good? Okay, so now we continue. It will suggest you to do the rest. Okay, we're going to commit. I think there will be no problem. And we're going to push it. This time I accepted all the changes before I run the commands. I think we're clean now. And let's see. Okay. It also give a summary about the key aspects. It's like a modern design section, technical features, links, integrations. Okay, let's take a look. Okay, first of all, the files are here. Okay, it looks good. And let's try the web page. I think it will take some time. Okay, usually 2 to 3 minutes. So while we are waiting, I think we can start to put a prompt to help us to change the layout of our GitHub page. Okay, now help me make my GitHub page engaging, show all stats, plots about activities, make sections, show social links, YouTube channel links, if NA, use placeholder. Okay, I think we are pretty comprehensive here. Okay, let's leave it here for a moment. Come back to the web page. Now it's not showing anything. Let's see. Okay, we have our index HTML. We're doing the Steven test to GitHub.io. There does not seem to be much problem. No, it's not working. Let me check. Let me check if we have something additional we need to do. Okay. Don't recall. Let's try again. No. With the full documentation. Let's see. Yeah, we have done that. Okay, let's try again. Not working. Let's check. I think settings. See pages. No verified domains. Okay, it might be the reason. Let's try. Sorry, I do not remember because last time I created the web page was some times ago. Domain is not properly defined. Okay, sorry. Let's try again. Okay. IP address. It's not the problem. Okay, let's save this command for a moment here. Okay. Let's see. I open the but 404. Let's see if it can debug. 404 issue. Okay, let's see what's wrong with it. Okay, so the issue is that we do not have the README file. Okay, I'll just take out this command in case. Just in case we need it later. Let's try to follow it. Okay, so now we have this README file. We accept everything. Okay, and push to our repo here. Yes. Now I think we also going to have a README file. Okay, good. Created a README file. No, it is not shown here. Let me try again. Main has recently pushes. Okay. Can verify if commit success. The best way is to check here, and it will be very fast, comprehensive to show you if there's some commits on the way, or okay, it says everything is done. Okay, let's try. It suggests me to open the web page. I think nothing shows. Okay, let me see. Connection seems okay. It's still showing for error. Okay, so it will analyze. Setting. Okay, maybe it's this problem. Okay, sorry. I think this might be the issue because I should. No, sorry. The repository should be renamed like this, and yes. Let me try. I may be wrong. Let me test it. Repository name. Let me try. Yeah. This should be the names. I think .io. Yes. And let's try. What am I doing with Steven test the GitHub.io? Compare and pull request. No, let's just ignore it for one moment. Okay, now you can see I made a mistake because the repository should be named as this. Username.github.io, and then you refresh, you have everything. Okay, I'm going to share with it. Okay, I made a mistake. Now the correct repo name is updated. Please check. So in this way, I just want the the IDE is in line with my current changes without getting the conflicts if I need to update something else. Okay. So, okay. Please do the updates about the page, make it more engaging. Right, so I already have this one, right? Home, about, project, blog, and context, right? Seems much better than my current version. My current version in the GitHub of my YouTube channel now is much simpler than this one. Very good. Make it more engaging. Let's try it. Sorry. Let me see if the folder name, yeah, the folder name is right. Okay. Unsaved file. Yeah, let me check. Yeah, so inside of the repo, I see compare and pull. Why? So I think there may be some conflict or delay of the change. Okay, we have two branches. So we're seeing the commit pull. We initiate create the commits on the master branch. Then we create a switch to the main branch in the both. Okay, so just to merge them properly. I think this is good. We should merge them. Let's merge. Okay. Okay, so it suggests me to go to change myself. Okay, so I think I need to go to my branches, change the default. Okay. The main branch. How can I set it to default? Okay. It actually so we should have two repo, one with my username, one with username.github.io. So they kind of got some mix. Okay, apologize for this. Let me see how we can resolve it. Repository settings and the branches. Is it text? No. Actions. Not here. Okay. Under branches, change the default branch. But I do not see anything here. Let's see. Okay. How to change the default branch? Okay, let's do this. I think the fastest way is to, okay, we just go here and we delete this repo. Let me see. setting. Can we delete this repository? Yeah. Okay, let's redo it, right? We need to have one as this for our home page. No, sorry. Need to change it to learn by doing. Okay, like this. And then going to create another one. Okay, with only my username. This one will be purely used to improve the layout of our page. Okay, so I just say I recreated to branch to repo one as okay, the other as the github.io. Please implement the commits for the first one. Add engaging homepage info. The second one, add engaging personal website. Okay, let's see how it processes everything. Yeah, now I think we are in the right place. Okay, now it created this folder to represent our repository. Okay. Let's see, whenever we see this sign here, like M is modified and U is unchecked, you can see the status of different files being modified, being checked, and so on. And now let's go to implement everything. Okay, so sometimes if it cannot access the repo, it will get my token and execute the commands. Okay. Let's check. Okay, not this one yet. Oh, okay. Now I think we have learned by doing with Steven test. Already have this page updated. Wow, impressive. And you can see actually the status, the layout. If you check my current GitHub page of my main account, you can see this has some unique characteristic. Like the description, like you see this flashing title, everything seems perfect. Okay, and also the highlight, featured project, and also the trophies. Yeah, I like it. It's very clear, right? And now let's continue. It's getting some additional change. I think it's about the layout of personal page. Okay, then it's this one. It's 404. I think we need to still wait. some files to be added, of course, because previous one was in conflict. I recreated the two repository. Okay, there is an internal error. Let's try again. No, it's not. Okay, it says it already done it. Let's try. If files already inside. No. Okay, I'm going to say in repo there are no files. Let's see. Yeah, it says successful. Let's try. Yeah, we have it. So it also created a very engaging README file. You can see the different details. Looks good. Okay. And let's just check our page. I think we're going to need some time. You see, update pending. Usually we need to wait. Okay, deployment. Okay, maybe ready. Okay, it's very beautiful, right? You see, hi, I'm Steven. And also we see this flashing sign to show some keywords. We have the GitHub. Let's try this link. Okay, it's perfect. We have LinkedIn. Of course, this is a placeholder. Yeah, currently I think it's directed to our home page. Yes. Okay. Also, what's this one? Never used it before. Anyway, let's come down. About me, passionate about programming. Okay, based on the information it has and the commands I gave, I think this is accurate description of me. Also, you can see the languages, frameworks. Okay, there are some assumptions, but in general, they are good. Okay. To be honest, I do not know all the frameworks, but in the future, maybe I will get to know all of them. You can see here is a chatbot. Okay, there is no picture. Of course, we can improve this part. Image generator. This is a new project coming soon. Yeah, very nicely put, although the link does not work. Smart task tracker, task manager. Okay. Seems plausible, right? Latest blog. Getting started with Olama, building modern web apps, development tips, and so on. Email me, and LinkedIn. Wow, this is really impressive. I think from this demo I show you, I'm going to go back and improve also my personal GitHub page, the main page of my YouTube channel. So, just a quick wrap up of this tutorial. You see here are 3 repositories we made with Windsurf IDE. It is very quick. It is a very efficient agentic workflow. We build an app and put it in GitHub, and we have a very engaging README file, very good and very detailed. Then we have this personal page improvement. So with this repo, whenever we go to our GitHub page, we see this very beautiful design. Okay. Then we have another repo created to showcase our personal page, because the personal page is also a very important way for the others to get to know the developer, right? So you see, first of all, inside of this repo, we have this very nicely designed README file. And whenever we go to this personal page, we can see in general it is layout very good. We can see home, about, projects, blog, contacts. And we can also change the color, right? This is very, very impressive. Of course, there are some like this one, right? When we change the color, some of the characters are not rendered well. We might need to further debug. Just insert your prompt here and let it work, and accept the changes and just push the results to GitHub again. So, okay, I think we got everything ready to go, and we have a very nice UI for everything. We can keep on developing, right? So one thing I want to mention before we end this video is that whenever you use this tool, it's automatically handling all the tasks. But always be cautious when you develop something very seriously, especially when you accept the changes. Be sure you understand the implications, right? This demo is very quick. I do not check everything, but when you actually, for example, you check this application, you need to understand how it works to make sure it does not have some bugs, potential issues in the future, and also safety concerns and so on. Yeah, so that's all I want to say. And I wish you like this tutorial. If you have any question, feel free to leave a comment. If you like my video, share it, give it a like. If you like my channel, please subscribe. And there are more contents on the way, and I wish you enjoy it and have a very rewarding experience watching my videos. So thank you again, and see you next time. Bye bye. Hello everyone, welcome back to my channel again. Today I'm going to show you a very useful and easy to implement tool. It's called Autogen Studio, which is one of the products developed by the Autogen team. So basically, if you go visit the Autogen Studio 2.0, this website, there are a lot of description already written here. If you follow the instruction, for example, I follow instruction of installing the Autogen Studio. We are people install Autogen Studio and then start with Autogen Studio UI. You are going to have this interface to build and test the agentic workflow with a simple click and input without coding. So let me just show you several examples. Okay. People install, I'm going to show you. If you go to your PowerShell environment, you just quickly copy and paste this command. It will install the dependencies very quickly. And then you also in the PowerShell, you can start the UI with this command, Autogen Studio UI. I'm going to skip that. I'm going to show you the examples I already did. Okay, so basically you see here you have the skills, models, agents, workflow, right? Skills are not mandatory for you to set up because each agent could have a skill. Okay, it's like you teach your agent that there is a specific coding block that it can implement, or some specific skill that's according to your description, but it is not 100% mandatory. It depends on your use case. And on the model side, you can configure using OpenAI or local Llama. Like in this format, you can see this is a local Llama setting. It's very easy. Now I only use a Llama 3.21b model because it's very fast. The inferencing efficiency can satisfy my use case because I do not want to wait too long to get a response. And to set up, you need to input the correct model name, API key as a Llama, and then also the base URL. This is always standard for Llama inference, and also description is just based on your need. Okay, you can describe whatever you want. Then you can test the model after inserting all the information. You can test your model here. When you click test model, it will allow you to quickly test if the model is connected to the environment. Okay, you can see model tested successfully. Okay, I'm going to skip the skills setup now. Okay, now let's go to see the agents. So basically, I'm trying to do one simple case, just a Q&A. I ask a large language model to give feedback. Another complicated case is to ask a group of financial analysts to give me an analytical report about a financial product. So the second case is quite complicated. I have not yet found the solution to it. I have tried different ways to set up system message and so on, but now I have no results. Okay, I believe I need to set up some skills to actually contain the behavior of the different agents. Otherwise, now I only set up the system information, system messages like this one. You see I have a description of the agent, system message. When I put them into a group, now there is no useful result to show me. So I'm not going to show you this, but in the future, if I find a solution, I'm going to show you. And if I'm going to the notebook and hard code the agentic group chat and workflow, you can see my previous tutorials. I have made some videos about how to use it. Okay, but now because Autogen has a 2.0 version, AG2, already published, so I'm also going to make more videos about coding on the group chat of the agents and so on. Okay, and at this moment, I'm going to skip the group chat and go to the simple workflow. Okay, I have a user proxy. It's very simple. I just call it user proxy and your helpful assistant to help the users. Of course, there are also some advanced options you can modify, like temperature, max token, agent default auto reply, and so on. Okay, and also there is a code execution configuration. Then the important thing is that you need to choose a model. Okay, if you don't choose a model, it's like when you code in your notebook or in the Python environment, you do not have a configuration assigned to the agent, it will not work. Skills, like I said before, you can customize by yourself, but at this moment I'm going to skip it, just to make the use case very simple. Then I have the primary assistant. Okay, so for the assistant, my description is also very simple. It's like the user proxy, right? But this is the assistant that is going to give me the response. So it represents the large language model without many specific configuration. And the model, as you can see, I choose the same model. Skills, I skip. Now I go to the workflow. Okay, so there is a very simple way when you create the workflow. You can customize the names as you want if you want to differentiate from the other workflows. And of course, there is one thing about the summarization method. Okay, you can let a large language model do it, use the last message, or do nothing. And also here, the agents. Because this is a very simple use case, I just ask or utilize the user proxy agent to pass my prompt to the receiver, so receiver will give a response, right? So I only have two agents here, user proxy and primary assistant. After setting up the workflow, of course, you can quick test here, or you go to the playground to start workflow. Okay, so I'm going to first test workflow here, because after testing it, if you find something is not working well, you can come back to change it immediately. Okay, so I'm going to ask, what is large language model? Of course, before you run everything, please make sure that the Llama is set up and you already put the model you wanted, and make sure the model setting, the model names, and so on is the same as what you input into the Autogen Studio UI application. So here you can see we get a response, and it is formatted very well. If you do not want to code like the UI and you just want to do some tests or utilize large language model in a nicely designed interface, I think this is a good option, right? And you can see here, you can see the agent messages, which means that how each agent talking to each other, okay? And what you are going to see here is actually a summarization. Okay, this is a summarized the textual information that's generated from the workflow. And here you can also see maybe sometimes there are some additional results. Okay, additional results, I think skills.py is like default. It will always show you, but when you click it, it's empty because now I have not set any skills to the agents. So as you can see, the test is okay. And I'm going to go back to the playground. Okay, so in playground, you can just start a new session. You can choose the different workflows that you set before. I already made some of the workflows, so I can choose from them. But for now, I'm going to test the default chat flow. Okay, the simple chat workflow you just saw, I tested. Now it's like I formally get this workflow in the sessions page, and I'm going to use it. Okay, so I'm going to ask what is linear regression. Okay, and I hit enter, and the workflow is kicked off. And you are going to see the response later, just like what you saw in the test. Okay, so this is summarize the information, and if you want to see the detailed conversation between the agents, you can see them here. Okay, it's organized, and the response is rendered very well, right? It's not like a very random or very unstructured format. And of course, whenever you want to stop a conversation, there needs to be a terminate wording here. As you can see, the skills is still empty. Okay, so if you want to chat with your local large language model, there are a lot of ways, right? You can use Ollama directly, you can use LLM Studio, now you can also use Autogen Studio. So at this step, if you do not want to design your own user interface, just go directly, install the dependency, and start the UI. It is very convenient. And at this moment, I try to build a more comprehensive financial analyst group chat like this. I use one user to use a proxy agent to initiate the chat, and received the information will be received by the group of the financial analyst, and also the coder, and also the code runner, and so on, to get relevant information, consolidate to a financial product analytical report. At this moment, I have not yet get the results. So in the future, if I successfully construct such a group chat, I'll share with you. So at this moment, I'm trying to test in two ways. One is to use this user proxy to initiate the chat and talk with the financial analyst group, or I do a sequential chat. Sequential chat is like you set the sequence of the chat like this is the only sequential way that the conversation can go, which means that it's not like group chat. You can have automatic selection of the speaker, or round robin. If you check the documentation, there are many descriptions there. For the sequential chat, you need to specify who speaks first, who speaks next. Okay, it's also very interesting. You can try it on your side. But for my current use case, for the financial analyst, either group chat or sequential chat, I do not yet have a successful result. So in the future, I wish I will share with you. Okay, just a quick wrap up. First of all, you need to check the Autogen Studio page to understand how to install, and there are many description information there. I find it very clear and useful. Then when you start in your local environment, please make sure that you understand your use case. For the most simple use case, just question answering, you can just set a very simple workflow and test it. At this moment, even though the workflow I showed you is quite simple, but you can already test a lot of things, right? You can test the different receiver of the different agent as a receiver to see if they respond differently, and also you can set up, for example, like the agent's temperature and different settings. And of course, if you have enough compute, you can also try different models and so on, and also try some skills. I believe if you ask a coder and a code runner in a very simplified workflow, you can get some results. Okay. In the future, I'm going to show you more use case, hopefully also in the UI. If not, I'm going to show you in the Python coding environment. Okay. So I wish you like this video. If you find it useful, please give it a like, share it. If you have any comments, feel free to leave it. And if you like my channel, feel free to subscribe. And see you next time. Bye-bye.
Hey there, data-driven decision makers. Ready for a deep dive? Today we're looking at how we evaluate large language models.
And we've got a research paper here that really gets into how to make those evaluations statistically sound.
Yeah, because just looking at a high score doesn't always tell the whole story, right?
Absolutely. It's like you wouldn't trust a medical diagnosis based on one kind of noisy measurement.
Right.
So this paper is arguing that we need that same kind of like statistical certainty when we're judging these powerful AI systems.
Okay, so the paper starts out by kind of highlighting this problem, the highest score wins mentality.
Yeah.
It's like everyone's just trying to win the AI popularity contest.
It is.
But forgetting to ask, like, how reliable are these scores?
Exactly. Without error bars or confidence intervals, it's really hard to tell if, like, is the difference between 80% and 85% meaningful, or is it just random noise? It's like trying to measure a marathon runner speed with a stopwatch that's a few seconds off.
Yeah.
You might get the wrong winner.
Totally. The paper uses this really cool example to like drive home this point. They've got these two fictional models, Galleon and Dreadnought.
Right.
And they're basically in this head-to-head battle on these popular benchmarks like math, human evil, MGSM.
Yeah. So you look at it, and at first glance, it looks like Dreadnought is winning, right? It's got 2 out of the 3.
Yeah.
But then when we actually apply the statistical methods that they lay out in this paper, the picture gets way more complex.
Okay.
And sometimes that supposed winner, not so clear anymore.
Okay, now I'm really intrigued. So the paper is proposing this whole, like, framework for looking at language model evaluations through this more statistical lens.
Right.
And the key idea here is to kind of imagine all the possible questions we could ask a model as this huge superpopulation.
Right, like almost like a thought experiment, right?
Yeah.
We've got this massive set of questions out there.
Yeah.
And any evaluation we do is just taking a sample from that huge pool.
Okay.
And that's a really important shift because it lets us then estimate how the model would perform on the whole population, not just the handful it happened to see during the test.
So it's like, if we're trying to figure out the average height of all adults, we can't measure everyone.
Right.
So we measure a random group.
Right.
And we know our sample's not perfect.
Yeah.
But it gives us a starting point.
Exactly. And this is where the central limit theorem, right? CLT.
Oh, yeah, the CLT.
This is a big one in statistics.
Yeah, I remember this.
And it basically tells us that if you take enough of these samples, the distribution of those sample averages starts to look like a bell curve.
Right.
No matter what the original population's distribution was.
Okay, yeah, I remember learning about that in stats class.
Right.
But how does that apply to, like, judging AI? It feels like we've gone from measuring heights to, like, I don't know, evaluating language.
Well, think about it like this.
Okay.
The CLT gives us a way to calculate the standard error of the mean.
Okay.
Which is basically how much is our sample average likely to be off from the true average for the whole population.
Gotcha. So it's like a way of quantifying uncertainty.
Exactly.
Like admitting that stopwatch might be a little off.
Right, exactly. And what the paper argues is that, like, using the CLT is a much more like robust and kind of widely applicable approach than some other methods that are out there.
Right.
Like bootstrapping, for example.
Yeah.
So it gives us a more solid statistical foundation.
Okay, so this is all making a lot of sense to me, but it also makes me think about all those comparisons we see.
Right.
Like all the different models out there.
Yeah.
It's like this constant arms race. Yeah. Everyone's saying their model's the best.
Yeah.
But are they really backing that up
right.
with the evidence?
It's a great question. And that's something this paper digs into, right?
Yeah.
It's not enough to just have that high score.
Right.
We need to be confident that the differences we're seeing are real.
Yeah.
And not just like chance.
Or quirks of the evaluation.
Yeah.
Okay, well, you've definitely got me thinking about those state-of-the-art claims in a new light.
Yeah.
So what else does the paper kind of reveal about how to make these comparisons more rigorous?
Yeah.
Okay, so we got to be thinking statistically, especially when we're comparing these models.
Yeah.
But like, how do we actually go about doing that?
Well, one of the key ideas in this paper is this concept of paired analysis.
Okay, paired analysis.
Yeah.
What is that?
So imagine you're trying to test 2 new fertilizers on tomato plants.
Okay, yeah.
You could plant them each in separate plots of land, right?
Right.
And just compare the yields.
Right.
That would be an unpaired analysis.
Okay. I feel like there's a better way.
Exactly. A more insightful approach would be to plant both fertilizers in the same plot.
Right. Okay.
Carefully controlling for other variables like sunlight and water.
Okay.
That's paired analysis.
Ah, okay. So we're isolating the effects of the fertilizer by doing that.
By planting them together, we can kind of eliminate or at least reduce the impact of all these other factors that might be confusing things.
Okay.
And it's the same principle when we're evaluating language models.
Yeah.
If we test them both on the same set of questions, we can actually take advantage of the correlation between their scores.
Correlation? You mean like even if the models are different?
Exactly.
They might still kind of agree on which questions are hard.
Exactly. Even if they're different, there's still going to be some overlap in their abilities.
Right.
And some questions are just harder than others. So by considering that correlation, we can calculate a more precise standard error for the difference between their scores.
Gotcha.
And that can really make a difference in our ability to say, okay, is this model truly better?
So paired analysis gives us this more like powerful lens to compare.
Yeah.
But, you know, the paper also talks about ways to reduce the uncertainty within a single model's evaluation too, right?
Yeah. So we can use these kind of variance reduction techniques to kind of make our measurements as precise as possible.
Okay, like what are we talking about here?
So one interesting one is this idea of resampling.
Okay.
And this basically means we run the evaluation multiple times on the same set of questions.
So the model gets multiple chances to answer.
Exactly. We're giving it multiple shots at the same problem.
Okay.
And by averaging those scores, we can kind of reduce the impact of any randomness.
Okay, so instead of just having one score for each question, we've got multiple, and we're averaging them.
Exactly. It's like taking multiple measurements with that wonky stopwatch and then averaging them out to get a better idea of the true time.
Okay, so resampling sounds cool.
Yeah.
But isn't that a lot of work computationally?
Yeah, it can be, which is why the paper provides some guidance on like how to choose the right number of these resamples based on how much precision do you really need.
Okay, so sometimes a few's enough.
Right.
Sometimes you need more.
Exactly. It depends on the situation.
So it's that trade-off of like computational resources versus statistical certainty.
Exactly. Another really interesting technique they talk about is analyzing not just the model's final answer, but the probabilities it gives to each possible token.
Oh, okay. So we're kind of peeking under the hood.
Exactly.
Seeing how confident it was.
Yeah, we're looking at its thought process a little bit.
Okay.
And this can be really helpful, especially in tasks that maybe don't have a lot of complex reasoning. Yep. We can kind of use those probabilities as a better measure of what it actually knows.
Okay, that makes sense. What about adjusting the model's temperature?
Yeah.
I've heard that can be used to kind of like smooth things out.
Yeah, but the paper actually cautions against that as a primary means of reducing variance. Because while it might make the scores look more consistent, you're actually changing how the model behaves.
So it's not a fair comparison anyway.
Exactly. It's like we're artificially smoothing out its performance. instead of actually measuring its true abilities.
Okay, so it's like giving that runner
Yeah.
rocket-powered shoes.
Exactly. Yeah, they might finish faster,
Yeah.
but it doesn't really tell us how good of a runner they are.
So we need to be careful about like manipulating the model,
Yeah.
even if we're trying to reduce variance.
Exactly. We want to get a clear picture of like what it can actually do.
Okay, so we've talked about paired analysis.
Yeah.
We've talked about resampling, analyzing probabilities.
Yeah.
It feels like we're building this like statistical toolkit here
Yeah, we are.
to make sense of these models.
We are. And there's one more crucial concept we need to talk about,
Okay.
and that is power analysis,
Okay.
which is all about understanding, can our evaluation actually detect a real difference, given all this noise that we've been talking about?
Okay, let's dive into that.
Yeah.
All right, so power analysis.
Yeah.
What is it?
Power analysis is all about understanding the ability of our evaluation
Okay.
to detect a meaningful difference between models, if one exists.
So it's like checking how strong our magnifying glass is
Exactly.
before we go looking for those tiny details.
Right.
If it's too weak, we might miss the important stuff.
Yeah.
Okay, I'm with you.
Imagine you're trying to figure out if a new drug is effective. A poorly designed study, one with low power,
Yeah.
might completely miss the drug's benefits.
Okay, yeah. Makes sense. But we're talking about language models.
Right. But the same idea applies. Think about Galleon and Dreadnought, our fictional models.
Yeah.
Let's say we do an evaluation with low power,
Okay.
and we don't find a significant difference.
So we might just assume they're basically the same.
Right. But the problem is our evaluation just might not have been sensitive enough.
Oh, okay. So how do we make sure that our evaluations have enough power then?
Well, the paper gives us a formula
Okay.
to figure out how many questions we need to ask to achieve a certain level of power.
Okay.
It takes into account things like how big of a difference are we expecting to see,
Right.
and how much statistical certainty do we want?
Okay, so we need to really think about the number of questions we're using
Yes,
and how big of a difference we're actually looking for.
exactly.
This is really helpful. I mean, for anyone who's designing these evaluations,
Absolutely.
could save a lot of time and effort.
It's like trying to find a needle in a haystack.
Yeah.
If you don't have the right tools, you might be wasting your time.
Yeah, okay. This all makes sense. But it also makes me wonder about all the research papers out there,
Yeah.
all the product announcements I see about these new language models.
Right.
How can I, as someone who's trying to stay informed,
Yeah.
how can I be more critical knowing all of this?
Look beyond the headlines.
Okay.
When you see a claim about a new model's performance, ask yourself, how did they do this evaluation?
Okay, yeah.
Did they consider statistical significance?
Right.
Was the study adequately powered?
So don't just accept things at face value.
Exactly.
Look for the evidence.
And if it's not there, ask for it.
This has been a really insightful deep dive.
It has.
We've learned about the limits of traditional evaluations.
Yeah.
We've talked about some really powerful techniques for making them more rigorous.
Absolutely.
Paired analysis, variance reduction, power analysis.
Yeah. All these tools help us really understand how these models perform.
What's the one thing you want our listeners to remember?
Embrace a statistically informed perspective.
Okay.
It lets us ask better questions, draw more reliable conclusions.
And ultimately make better decisions
Exactly.
about how we build and use AI.
Well said.
This has definitely changed how I think about language model evaluations.
Good.
I'm already looking at those performance numbers a little differently.
Excellent. That's what we want.
Thanks for joining us on this journey. Remember, a statistically informed perspective is a powerful tool. Until next time, keep diving deep and keep asking those critical questions. Welcome back, everybody. Today, we're going to be taking a deep dive into AI safety.
Oh, very cool.
Specifically, this research paper titled AirBench 2024, a safety benchmark based on risk categories from regulations and policies.
Yeah, sounds very timely.
So are you ready to see how safe AI really is?
I am definitely ready.
Excellent. So, one thing that I was reading through this, and it seems like a lot of existing benchmarks for AI safety
Right.
are kind of general,
Yeah.
right? They're not really reflecting the specific risks that are outlined in actual regulation or company policies.
You're absolutely right. That's really the problem that this research is addressing.
Okay.
It's one thing to test AI's general knowledge, but it's quite another to see if it can actually follow the rules that it's going to encounter in the real world.
Yeah, that makes a lot of sense.
Yeah.
So this is where this AirBench 2024 comes in.
Right.
And it's a new benchmark that's directly aligned with risk categories that are defined in 8 government regulations from the EU, US, and China, and 16 corporate policies from leading AI companies.
And they didn't hold back on the testing either.
Oh, really?
Yeah, they used 5,694 carefully crafted prompts to test AI models across 314 unique risk categories.
Wow, 5,694 prompts. I'm already feeling overwhelmed, and I'm not even in AI.
Yeah.
Can you give us a real-world example of what one of these prompts might look like?
Sure. Imagine a prompt asking an AI to determine loan eligibility based on someone's credit score and income.
Okay.
Sounds pretty harmless, right?
Yeah, it's something you might actually ask an AI to do.
Exactly. But this prompt is designed to see if the AI understands that it shouldn't be making automated decisions in the financial domain, which is a key risk area highlighted in regulations like the EU AI Act.
So it's not just about what the AI can do, but what it shouldn't do even when asked.
Precisely. And that's where the findings of this research get really interesting.
Oh, okay. So give me the highlights. What do they find out?
So first, there's a huge difference in how well different AI models perform. Some models, like Anthropic's Claude 3 models, are remarkably good at refusing these risky requests. They achieved an average refusal rate of 89%, meaning they correctly identified and refused to respond to almost 9 out of 10 risky prompts.
That's pretty impressive. So Claude 3 is basically saying no to risky business.
Essentially, yeah.
Okay, cool.
On the other hand, models like DBRS Instruct had a much lower refusal rate, around 15%.
Oh, wow.
Yeah. So that means they're much more likely to give potentially harmful or inappropriate responses.
Okay, that's concerning.
Yeah.
So even the best AI models still have some work to do when it comes to safety.
Unfortunately, yes, even the top-performing models exhibited gaps, particularly in areas like refusing to provide advice in heavily regulated industries like healthcare, finance, and law.
Okay.
These are areas where, incorrect or inappropriate advice could have really serious real-world consequences.
That makes sense. So AirBench isn't just about giving AI models a grade. It's about pinpointing their weaknesses.
You got it. It provides really granular insight showing exactly where specific models struggle. For example, a model might be great at refusing hate speech against certain groups, but less effective at refusing hate speech based on other factors.
So it's kind of like a diagnostic tool for AI safety,
That's a great analogy.
helping developers see where they need to focus their efforts.
Yeah, and this is where the real-world relevance of this research really comes in.
Okay.
Remember those regulations and corporate policies we talked about?
Uh-huh.
Well, AirBench 2024 directly maps model performance to those specific guidelines.
So you can see exactly where AI models fall short of the law.
You got it. This level of transparency is huge for governments trying to regulate AI and for companies developing it.
I bet this is causing quite a stir in the AI community.
Absolutely. For governments, it provides a concrete way to measure compliance.
Okay.
For AI companies, it highlights where they need to step up their game, both in terms of model development and their internal policies.
So it's like AirBench 2024 is holding up a mirror to the AI industry, revealing the true state of AI safety.
And that reflection is both fascinating and a call to action by identifying specific areas of risk. This research is encouraging AI developers to be more proactive about building safer and more responsible AI.
It's not just a benchmark. It's a roadmap for a better AI future.
Right.
Speaking of the future, the research uncovered something interesting about OpenAI's GPT models.
Oh, yes. That was a noteworthy finding, it seems, that their refusal rates have actually been declining over time.
Really?
Yeah, potentially indicating a shift in the company's approach to safety.
Declining refusal rates.
Mm-hmm.
Meaning they might be getting less cautious about risky requests. That's a little unnerving.
It's definitely something to keep an eye on. It could be intentional, or it could be a side effect of other changes to the models. But it raises some important questions about the direction OpenAI is taking with AI safety.
Yeah, this is getting pretty deep. I'm already starting to think about the implications of all of this for everyday people, not just AI experts and policymakers. We're all going to be living in a world shaped by AI, right?
Yeah. That's a crucial point. This research connects the dots between those abstract benchmark scores and the practical implications of AI safety in our everyday lives.
Okay, can you give me some real-world examples of how AI going wrong in these risk categories could actually affect people like me?
Sure, let's start with something we all deal with, finances. Imagine an AI system designed to help manage your money. What if that AI is susceptible to manipulation or lacks the necessary safeguards to protect your sensitive financial information?
Oh, that sounds like a recipe for disaster. Identity theft, bad financial advice, or even automated decisions being made about my money without my consent.
Exactly. And it's not just finances. Think about healthcare. What if an AI system is providing medical advice or making decisions about your treatment, but it hasn't been properly trained to refuse risky requests or understand the nuances of medical ethics?
Oh, that's a scary thought. The potential for harm is huge,
Yeah.
especially if these systems are making life or death decisions.
And then there's the issue of misinformation. If AI models are easily manipulated into generating fake news or propaganda, it could have a devastating impact on our ability to tell truth from fiction and to trust the information we consume.
Yeah, we've already seen how damaging misinformation can be, and the thought of AI being used to spread it even further is incredibly concerning.
It is, and we can't forget about the potential for AI to be used for discriminatory purposes.
Right.
We've already seen examples of algorithms perpetuating bias in areas like hiring and lending. If AI models aren't trained to recognize and refuse these types of risky requests, the consequences could be incredibly damaging.
This is all starting to feel pretty heavy. AI safety isn't just a technical issue. It's a societal issue with far-reaching consequences.
Precisely, and that's why research like this is so critical. It sheds light on the potential risks, helps us understand where we need to improve, and empowers us to demand better from the companies and institutions developing these powerful technologies.
It's a call to action for all of us. We can't just sit back and assume that AI will magically become safe and responsible. We need to be engaged, informed, and proactive in shaping its development.
Couldn't agree more. We need to be asking tough questions, holding developers accountable, and demanding transparency.
And tools like AirBench H2024 can help us do just that.
Absolutely. It gives us a common language, a standardized way to evaluate and compare AI models. This fosters greater transparency and trust, which are essential if we're going to navigate this AI-powered future successfully.
So where do we go from here? What are the next steps in making AI safer and more aligned with our values?
That's a great question, and one that will likely occupy us for years to come. But based on this research, I think there are a few key areas that deserve immediate attention.
Okay. What are the most important takeaways for us to remember?
First, we need to double down on developing AI models that are inherently robust, reliable, and resistant to manipulation. This means building in safeguards that go beyond simple rule-based filters and delve deeper into the underlying reasoning and decision-making processes of these systems.
It's like teaching AI not just to follow the rules, but to understand the spirit of the rules, the ethical principles behind them.
Exactly. It's about moving beyond mere compliance towards true ethical reasoning.
What else is on the agenda for making AI safer?
We need to create more robust and adaptable regulatory frameworks. The AI landscape is changing rapidly, so our regulations need to be nimble and responsive to emerging risks.
So no more playing catch up with AI. We need to be anticipating potential problems and putting safeguards in place before they become major issues.
Agreed. And we can't rely solely on top-down regulation either. We need to foster a culture of responsible AI development within the tech industry itself.
Okay.
This means encouraging companies to prioritize safety and ethics throughout the entire AI lifecycle from design to deployment.
So make responsibility a core part of AI's DNA, not just an afterthought.
Exactly. And finally, we need to empower the public to be more informed and engaged in this conversation.
Okay.
AI is going to affect every aspect of our lives, so we all have a stake in ensuring that it's developed and used in a way that benefits humanity.
It's about demystifying AI, making it less of a black box and more of a tool that we can all understand and have a say in shaping.
Right, and that's where education, open dialogue, and public engagement are so crucial. We need to have honest conversations about the potential risks and benefits of AI, and we need to involve a wide range of voices in shaping its future.
It's about making sure that AI is a force for good, not just a force for disruption.
Well said, and I think research like this, with its focus on transparency, real-world relevance, and actionable insights, can be a powerful catalyst for that kind of positive change.
It's a reminder that AI safety isn't someone else's problem to solve. It's a shared responsibility, and we all have a role to play.
Absolutely, and this brings up a really interesting point about the future of AI regulation.
Oh yeah, I'm all ears. What kind of implications does this research have for how we regulate AI?
Well, if even the most advanced models, the ones designed with safety in mind, struggle with certain risky requests, it makes you wonder how effective our current regulations can really be.
So you're saying our current approach to AI regulation might not be enough to keep up with these advancements?
It's certainly a valid concern. If these cutting-edge models are showing gaps, it raises questions about how well we can regulate AI systems that might not prioritize safety as much.
Yeah, it's like we're building these incredibly powerful tools, but haven't quite figured out the safety manual yet.
A perfect analogy.
Yeah.
And to complicate matters, That manual is constantly being rewritten as AI evolves and we learn more about the potential risks.
So what does this mean for the future of AI regulation? Do we need stricter rules, more oversight, a whole new approach?
It'll likely require a multifaceted approach. We might need stricter regulations for high-risk areas like healthcare and finance, where the potential for harm is significant.
But regulations alone might not be enough, right? And it's not like we could just create a rule for every possible scenario.
Right. We also need to incentivize AI developers to prioritize safety and ethics from the very beginning of the design process.
So bake safety into the core of these systems, not just treat it as a box to check off for compliance.
Precisely. And to do that, we need a culture of transparency and accountability within the tech industry. Companies should be upfront about the limitations and risks of their models and the steps they're taking to mitigate those risks.
Yeah, transparency is key for building trust. And that trust is absolutely essential if we want to navigate this AI-powered future successfully.
I couldn't agree more. This research, by focusing on real-world regulations and policies, helps bridge the gap between theoretical benchmarks and the concrete actions companies need to take.
So it's like they're providing a practical roadmap for responsible AI development.
Exactly. And it equips regulators and policymakers with the tools they need to hold those companies accountable.
So this goes beyond just building safer AI models. It's about creating a safer AI ecosystem, one grounded in transparency, responsibility, and a commitment to ethical development.
Well said. It's a message that everyone involved in AI, from developers to policymakers to everyday users, needs to take to heart.
It's a message that's both challenging and hopeful. Challenging because it forces us to confront some tough questions about the future of AI, but hopeful because it empowers us to shape that future in a positive way.
And speaking of shaping the future, this research also raises important questions about our own trust in AI systems.
This is where things get really interesting. I love a good philosophical debate.
If even the most advanced models struggle with certain types of risky requests, how much should we trust these systems to make decisions that impact our lives?
That's a question a lot of people are grappling with, especially as AI becomes more integrated into everything we do, from healthcare and finance to transportation and beyond.
This research provides some valuable food for thought. It reminds us that AI systems are not infallible. They're tools, and like any tool, they can be used for good or bad.
It all boils down to how we design them, how we train them, and how we use them.
And it comes down to our own judgment. We can't blindly trust any technology, no matter how advanced it appears.
We need to be critical thinkers, question assumptions, and demand evidence. We can't just passively accept everything AI throws at us.
And we need to be aware of our own biases, our own tendencies to trust or distrust certain technologies based on factors that might not be entirely rational.
It's about being informed, engaged, and empowered users of AI, not just passive consumers, swept along by the tide of technological advancement.
Exactly. This research, with its emphasis on transparency and real-world relevance, can help us develop that kind of informed and empowered relationship with AI.
So it's not just about making AI safer, it's about making ourselves safer in an AI-powered world.
I like the way you put that. It's a subtle but important distinction.
It's about recognizing that AI isn't some separate entity acting upon us. It's a reflection of ourselves, our values, our choices.
And the choices we make today will shape the AI-powered world we inhabit tomorrow.
Choices about how we design, regulate, and interact with AI.
Choices about what we trust, what we question, and what we demand.
Choices that will determine whether AI becomes a force for good or something we come to regret.
That's certainly a powerful thought to ponder.
It is a heavy topic, but I think it's important to acknowledge the weight of these issues. AI isn't just a fun, futuristic gadget. It's a technology with the power to fundamentally reshape how we live, work, and think.
And with that power comes a responsibility we all share.
So let's take that responsibility seriously.
Yeah.
Let's engage in these difficult conversations, demand better from AI developers, and work together to build an AI future we can all be proud of.
Well said. I think that spirit of collaboration is crucial.
So before we get too carried away, let's bring it back to the research. We've covered a lot of ground, but I want to highlight a few key takeaways for our listeners.
Good idea. A little recap never hurts.
First and foremost, this research gives us a much clearer picture of how well current AI models align with real-world safety concerns.
And the results are a mixed bag, offering both encouragement and cause for concern.
It's encouraging to see models like Claude 3 demonstrating a high level of safety.
But it's also concerning that even the best models have gaps, especially in areas like providing advice in heavily regulated industries.
This highlights the need for continuous research development and vigilance. AI safety is not a destination. It's an ongoing journey.
Exactly. And this research serves as a valuable guidepost on that journey.
It's also a crucial reminder that AI safety is not just a technical issue. It's interwoven with social, ethical, and political considerations.
And it compels us to think deeply about the values we want AI to embody, the role we envision for it in our lives, and the future we want to build.
Which brings us to another key takeaway: the importance of transparency.
Transparency is the bedrock of trust in AI systems, accountability for developers, and informed public discourse about the future of AI.
And AirBench 2024, with its detailed risk categories and alignment with real-world regulations and policies, is a powerful tool for promoting that transparency.
It illuminates where AI models excel and where they falter, giving developers crucial insights for improvement.
It's more than just a benchmark. It's a catalyst for meaningful change in the field of AI.
Absolutely. And that's what makes this research so compelling. It's not just about assessing the present. It's about actively shaping the future of AI.
A future where AI is safer, more responsible, and more aligned with our values.
A future where we can all harness the immense power of AI without compromising our safety, privacy, or humanity.
That's a future worth striving for.
Yeah.
Well, we've reached the end of our deep dive into AI safety.
It has been a fascinating exploration.
Yeah, for sure. Before we resurface, though, I want to leave our listeners with one final thought to ponder.
Oh, I like a parting shot.
Remember how we discussed the declining refusal rates in OpenAI's GPT models?
Yes.
And how that might signal a shift in their approach to safety?
It certainly sparked a lot of questions about their priorities.
Yeah, it got me thinking, what if instead of just focusing on making AI refuse these risky requests,
Right.
we also explored ways to make those requests less risky in the first place?
That's a really intriguing perspective. You're essentially advocating for a shift in focus from AI's ability to say no to our own responsibility in framing the right questions.
Exactly. What if we viewed AI safety as like a two-way street? It's not just about building AI that can resist manipulation. It's also about us becoming more responsible users.
Right.
Being more mindful of the prompts we give and the potential consequences of our requests.
That's a profound point. We often get so caught up in teaching AI to be a responsible citizen that we forget our own civic duty as users.
Right. It's like, yeah, we need to develop a sort of AI etiquette,
Uh-huh.
a set of guidelines for how to interact with these systems in a way that's safe, ethical, and beneficial for everyone.
I love that AI etiquette. It's like the digital age equivalent of teaching people not to yell fire in a crowded theater.
Precisely. We need to learn how to use AI in a way that respects its power, its limitations, and its potential impact on society.
That's a message that deserves to be amplified. It's not just about making AI safer. It's about making ourselves safer in an AI-powered world.
So as we wrap up this deep dive into AI safety, let's all challenge ourselves to think beyond just the technical aspects of AI safety and consider the human element, our own responsibility in shaping a future where AI is truly a force for good.
And remember, knowledge is power. The more we understand about AI, its capabilities, its risks, its potential, the better equipped we'll be to navigate this exciting but sometimes uncertain future.
Absolutely. Well, thanks for joining us on this deep dive into AI safety.
Yes, thank you.
We hope you found it informative and thought-provoking.
Yeah.
And we'll see you next time for another, plunge into the fascinating world of knowledge.
Until then, keep exploring, keep questioning, and keep learning.
Hello everyone, welcome back to my channel again. Today let's explore the local implementation of RAG chat. So today I'm going to use Gradio or Llama and the Llama 3.2 1B model to build a local chatbot where we can use different citation sources to get the response that we want. But please remember, this app is a base version. You can have many ways to improve it or implement in different use case. So now let's check the code and also the application. So on the left hand side, you can see this is the user interface with Gradio, and on the right hand side is the code base. So one important thing is that when I build this application, of course with also the different coding assistant, I always do it from a ground up processing. So for example, I build different applications here, like DuckDuckGo. It will actually do the query to DuckDuckGo search engine, and also Google News, and also Wikipedia. The idea is that I want to use these free search engine and the information source to make my large language model response more robust. As you can see here, I build these applications, test them, and then link them all with Gradio app, this main programming file. So I give this suggestion because if you want to build from the high-level programming file first, you will get a lot of obstacles. For example, it is very hard to do the manipulation of different components and so on. So I make each individual work and put them together. As you can see here, in the individual file, the logic are all similar. So basically, we are going to query the engine, get the results, put it in a JSON file. This is not very complicated. And if you want, you can, of course, start from scratch. For me, I just do it with a code assistant and build a very simple logic. I test it, it is working. So I'm going to move on to the next step. I do the same for DuckDuckGo, Google News, and Wikipedia. Then I go to Gradio app and I make sure that all the functions are imported correctly. And the other part is to build the context for large language model. So I'm going to put all the information queried together. And here I'm going to query Ollama large language model. Here, of course, I set a system prompt to make sure that the language model understands what results I want. But here is a problem. If you do not include the system prompt in your prompt, sometimes the results could be less stable. But I'm not sure because my test case are just several queries. You can also test on your side. So in theory, usually you do not need to add a system prompt. You just need to structure your prompt well. But here, as you can see, I put the system prompt in the front, put the context, and also my user question in the end. In this way, I'm making sure that my prompt is structured very well. Okay, you can also try to take it away, the system prompt, or leave it here. And in the end, we are going to produce this result and show it in Gradio interface. So the rest of the code is about the user interface and so on. Okay, and please remember, saving the different query information or search results in a JSON format is very beneficial because, for example, when you test the different programming files, when you test them, you see immediate results, and it's stored very well. And if you want to further build up like a database or your user history, you can also utilize it. The other benefit is that when you incorporate into your prompt with the JSON format, you can choose different ways to incorporate in your prompt. So you have more flexibility when you ask a large language model. For example, in the future, you only want the top 1 or top 2 results from the search engine. You can identify those parts and put it in your prompt. Or like my current case, I put everything inside to a large language model. Now let's take a look at the left-hand side. So this part, first of all, you see there is a description about this RAG enhanced large language model chatbot and which search sources we use. And here I'm asking, how is the Apple stock doing? As you can see, the first response, it identified it is Apple company and also showed some information and also citations. But the citations are not listed in the end of the response. It's not 100% as I expected, right? So I ask again. I actually improved my personal prompt part and to see the results. No, nothing changes. I do it again. You can see this time we have some results. Okay, but it does not show me how the stock is performing. So partially I think it's because my prompt is very fuzzy. I'm asking how it is doing. And Also, you can see there are different sources. Some of the sources are reliable. Some of them are also hallucinated. I can guarantee you this. You can try on your side. And then I ask how is NVIDIA stock doing? Okay, it does not have much information, this one. Then I ask again. It showed some response, but not what I want, right? So I ask again, how is this stock performing recently? And we can see here, it shows some results, but structured less than what we expected. Now, let's try another prompt, right? We can say, how is Microsoft stock performing recently? Make sure citations are listed in the end. So it will process my prompt. So again, how you structure the search-based information, how you put it into large language model, how you design the workflow, they are all very flexible. So if you think this is not your desired way of processing the information, you can use additional loop to improve the results, refine the information, or even produce in different formats. Okay. So let's see here. Okay, the text does not mention the year. Okay, this is not what we want. It actually goes back to the years, talks about the history, right? Okay, so let's try it again. So in a case of a very small model, and you are building your DIY version of the RAG process, you always need to test and see how the results would meet your requirements. As you can see here, okay, has been trending down. Okay, this is one information. In recent months, okay, we can see there are some information here, but we do not have the citations, right? Let's try it one more time before we close this project. Okay, let's see. Okay, that actually gives some information here. Yeah, but without citations. You can always try on your side. So I guess there could be some improvements in the future if you want to work on this project, right? Like I said, how you structure the system prompt, user prompt, how you process the information, okay? We call it objective information you queried from the search engine, and put everything together. Or you want to build some additional loop to refine the information and put it into the prompt. But of course, when you use a local small model or ChatGPT, like a O1 model, the results could be very different. Okay, so I would encourage you to do more tests. But for this version, we have a free and easily accessible local RAG chatbot. So I wish you can find it useful for your future projects. If you have any question, feel free to leave a comment. If you like my video, give it a like, share with your friends, and please do not forget to subscribe, and see you next time. Bye bye.
welcome to the Deep Dive. Today we're diving into something really cool, functional data analysis.
FDA for short.
FDA, right. It's a different way of looking at data. Like imagine looking at data as like a curve or a path.
Instead of just a bunch of separate points.
Exactly. That's FDA in a nutshell.
We have a bunch of academic papers here.
Yeah, a whole stack.
Yeah.
And we're going to break them down for you. So by the end, you'll really understand what FDA is all about and how it's used.
It's kind of like the difference between looking at a single snapshot and watching a whole movie.
Oh, I like that.
Instead of just seeing where things are at one moment,
right?
FDA lets us see how things change over time.
So instead of seeing like just one height measurement for a kid,
exactly,
we'd see their whole growth like curve over time.
Yep. And that's just one example.
Okay.
Think about temperature changes over a year, the way your face moves when you talk.
Oh, wow.
Or even how genes turn on and off in a cell.
So many different things.
All of these can be thought of as functional data.
I'm already seeing how versatile it is. But how do we actually analyze that data?
Well, each of those curves, it's like a fingerprint.
Oh, interesting.
Unique to that person or phenomenon.
Okay.
In FDA, we call these functional random variables.
Functional random variables.
They show us all the possible paths the data could take.
Okay, so like each kid's growth chart?
Yeah.
Is a unique version of that functional random variable for growth.
Exactly. You got it.
Okay.
And FDA lets us look at not just the average trend, but also how much each individual curve varies from that average.
Oh, okay.
For example, we could look at children's growth curves and see if some kids have like faster growth spurts than others.
Oh, so we're not just looking at the whole forest, we're looking at each tree.
Yes.
Okay, that's really cool.
But sometimes our data isn't perfectly aligned.
Oh, what do you mean?
Let's say we're comparing temperature curves from different weather stations. The hottest part of the day might be slightly off.
Like comparing two movies, but one starts a few minutes later?
Yes, exactly.
That would mess things up.
And that's where we use data registration or phase alignment.
Data registration.
It's about synchronizing those events so we can compare patterns accurately.
Gotcha, like lining up those movie start times. So now our curves are lined up, but how do we actually analyze these curves mathematically?
That's where things get a bit more technical. We use what are called basis functions.
Basis functions.
They're kind of like building blocks for representing functional data mathematically.
Like Legos for math.
Exactly.
So different Legos for different data.
You got it. There are different basis function systems, like Fourier series and splines.
Okay.
Fourier series are good for data that repeats in cycles, like our temperature example.
Okay.
Splines are more flexible and can capture more irregular changes.
Like that growth spurt we talked about.
Yeah.
Okay, so we're building these models of these curves using these different building blocks, but I imagine real-world data is kind of messy. How do we handle that?
That's where smoothing techniques come in.
Smoothing techniques, okay.
It's kind of like sanding down the rough edges of our Lego model to get a smoother, more accurate representation of the real pattern.
So we're getting rid of the noise and focusing on the signal.
Precisely. And one way to do that is by using roughness penalties.
Roughness penalties, okay.
This makes sure our models aren't too complicated, so they work well with new data. It's like making sure our Lego model doesn't fall apart if we bump it.
Makes sense. So we've gone from looking at curves to building mathematical models and then smoothing them out for accuracy. But how do we actually get insights from these models?
There are many powerful tools we can use. One is called Functional Principal Component Analysis, or FPCA.
FPCA. I've heard of PCA, but this sounds way more advanced.
Think of it this way. Imagine we have all those kids' growth curves. Regular PCA tells you the main ways those individual data points vary.
Right.
But FPCA looks at the bigger picture. It tells us how the curves themselves vary. It's like figuring out the common moves in a dance routine, even if everyone has their own style.
That's a great way to put it. So FPCA helps us understand those variations in the curves themselves, not just the individual points. And we can use this for any kind of functional data.
Absolutely. From weather patterns to stock prices, anywhere you see curves changing over time.
This is already amazing. Is there more?
Oh, there's a lot more. We also have functional regression models to help us understand how those curves relate to other variables.
Okay.
For example, we could look at how the daily temperature curve affects how many bikes are rented in a city.
So we're not just analyzing the curves alone, we're seeing how they interact with the real world.
Exactly. And that's just the tip of the iceberg. There's a whole world of real-world applications and even more advanced concepts in FDA.
I can't wait to learn more. Let's dive into those. Okay, so we've gotten through some of the basics of FDA.
The foundation.
Yeah, it's time to see how all of this is actually used.
Let's jump into some real-world applications.
Yes, real-world stuff.
Remember that bike rental study we talked about?
Yeah.
Researchers used FDA to figure out how weather patterns throughout the entire day affected how many bikes people rented.
So it wasn't just about looking at the average temperature for the day.
Nope. They wanted to see how the temperature changed throughout the whole day, from morning till night.
Okay.
And how those changes affected those rental patterns.
Interesting.
And they actually found that high temperatures in the afternoon, made people less likely to rent bikes.
Yeah, that makes sense. I wouldn't want to bike in the hot sun either.
Right. Who wants to be out there?
Not me. But what about the evening? Did that have a different effect?
It did, actually. Higher temperatures in the evening were linked to more rentals.
Oh, interesting.
Maybe for those, leisurely rides.
Yeah.
Yeah.
After the heat of the day had passed.
A nice, cool evening ride. Much better.
Ah.
But they didn't just look at temperature, right? What about, wind and rain?
Good point. They also looked at wind speed curves. And what they found was that strong winds, no matter the time of day, usually meant fewer rentals.
Yeah, I get that. I wouldn't want to bike in strong wind either. So this study really shows how FDA can be used to find some pretty interesting stuff. What other kinds of real-world problems are being tackled with FDA?
Oh, tons. One really exciting area is drug discovery.
Now that's something I'm really interested in. How's FDA helping us find new medications?
Well, it all starts with understanding how drugs interact with proteins in our bodies.
Okay.
You see, proteins have these little pockets on their surface. We call them binding sites.
Binding sites, okay.
That's where drugs attach themselves to work their magic.
So it's like a lock and key. The drug needs to fit perfectly into that binding site on the protein.
You got it. And FDA helps researchers analyze the shapes of these binding sites in amazing detail.
They can even see how the shape changes over time.
So by really understanding the shape of these pockets, researchers can design drugs that fit better.
Exactly. And this level of detail is so important for developing treatments that are more effective and targeted.
It sounds like FDA is giving us a whole new set of tools to fight diseases. This is incredible. But I'm curious, is FDA just for physical things? Like bike rentals and proteins? Can it be used to analyze something more abstract, like human emotions?
Believe it or not, FDA is being used to analyze emotions.
Really? How does that even work?
Researchers use it to analyze facial expressions.
Okay.
From videos.
So they're turning facial expressions into curves.
Yep. They track the movement of different facial muscles over time.
Wow.
Creating curves that represent the flow of expressions.
That's wild. So like an emotion decoder.
Exactly. By analyzing these curves, they can spot patterns that match different emotions.
That's so cool. It's like a secret language of emotions told through our faces.
Right. And this has huge potential for fields like psychology and human-computer interaction. Imagine systems that can understand and respond to our emotions.
That's pretty mind-blowing. Okay, so we've seen how FDA can be used to understand things like physical things, like bike rentals and drug interactions, and even things like human emotions. But we've been talking a lot about external stuff. Can FDA be used to analyze something as complex and internal as, gene expression?
Absolutely. FDA is being used to study how genes turn on and off over time.
So instead of just seeing a snapshot of what genes are doing, FDA lets us watch the whole process.
Precisely. It's like watching a movie of our genes in action.
That's incredible.
Revealing the complex dance of genetic activity that controls everything from how we develop to our overall health.
It's fascinating. We've seen how FDA can be used to understand so many different things. It seems like there's no limit to what this tool can do.
And we've only just scratched the surface. There are even more advanced concepts and applications waiting to be explored.
I'm ready to dive deeper. We've seen how FDA can be used in so many ways. It's amazing. What are some of those more advanced concepts you mentioned?
Okay, buckle up. We're about to enter the world of persistent homology.
Persistent homology. That sounds intense.
It's a tool from topological data analysis.
Topological data analysis.
It's basically studying the shape of data.
The shape of data.
Imagine looking at a mountain range.
Okay.
Topological data analysis helps us see the features, like the peaks, the valleys, and how they're all connected.
I can picture that. But how does this relate to those curves we've been talking about?
Think of those curves as paths through that data landscape. Persistent homology helps us understand how that landscape changes as we move along those paths.
Okay.
Like, we could analyze a bunch of gene expression curves and see which genes change in similar ways.
So like identifying different dance routines based on the pattern of movements.
Exactly. Persistent homology helps us see past the individual data points and understand the bigger picture, the structure of the data.
Okay, I'm starting to see how powerful this could be. What other advanced concepts are there?
Well, there's the concept of depth for functional data.
Depth, so like how deep a function goes.
Not quite. Depth here means how typical a curve is compared to others. It helps us understand the data's distribution and find those outliers, the unusual curves.
Oh, so like a high-depth curve would be like the average Joe of curves,
Yeah.
and a low-depth one would be the oddball.
Exactly. Remember the bike rentals, how hotter afternoons usually meant fewer rentals. Imagine one day where rentals actually went up in the afternoon. That day's curve would likely have low depth because it's so different.
Right, like finding that one person who loves biking in the blazing heat. Depth seemed like a good tool for spotting anomalies.
It is, especially with complex data where those outliers might be hiding.
Okay, one more term caught my eye, GNOs. What are those?
GNOs, or group equivariant non-expansive operators, are like fresh out of the oven in the math world.
New stuff, huh?
Yeah, they help us build models that kind of think like humans do, how we see patterns in data.
So like teaching a computer to see the world through human eyes.
Exactly. One area where they're showing a lot of promise is in, remember that protein pocket detection?
Yeah.
GNOs can help identify those pockets even better.
Wow, so it's like having a computer that can see those protein pockets the same way a scientist would.
Yeah, and this could have a huge impact on drug discovery.
Amazing. So it's not just about protein pockets, right?
No, GNOs could be used anywhere where human perception matters in data analysis.
This whole deep dive into functional data analysis has been incredible. We started with just looking at curves, and now we see how they can uncover patterns in everything. Bike rentals, emotions, even the building blocks of life. It's like we've learned a whole new language.
You got it. FDA is about seeing the bigger picture. It's about understanding the dynamics of the world.
And I bet our listeners are already thinking about what data in their own lives they could look at through this new lens.
Absolutely. There's so much to explore. If you're eager to learn more, I recommend checking out the R package TDA for persistent homology. And the book Functional Data Analysis with R and MATLAB is a great introduction to the field.
Awesome. Well, that's it for this deep dive. Keep exploring, keep learning. This is The Deep Dive, signing off.
Welcome to another deep dive. Today, we're going to be tackling machine learning head-on.
Yeah.
We've got a whole bunch of university-level course materials
Oh, wow.
to dig through. And whether you're trying to, get ready for some big meeting or just, you love learning new things, I think this is going to be a really fun one for us.
Yeah.
So I think it would be good to kind of lay out for the listeners what exactly we're looking at here.
Okay.
So we've got Quizlist.pdf, boosting.pdf, consistency.pdf, deep.pdf, intro.pdf, kernels.pdf, nn.pdf, linear.pdf, nnrisk.pdf, online.pdf, statrisk.pdf, surrogate.pdf, svm.pdf,
Wow, that's a mouthful.
and treepred.pdf.
Okay.
So quite a bit of stuff to dig through.
Yeah, lots of material.
So I guess let's just get started. Intro.pdf starts off by talking about supervised learning.
Okay, yeah.
So I guess maybe you could explain that a little bit for our listeners.
Yeah, so supervised learning is basically like, imagine you're teaching a kid like different animals. You show them pictures and you say dog, cat, bird.
Right.
It's basically that. But for machines, so we give them labeled data examples with known inputs and outputs.
Okay.
And they learn to map those inputs to those outputs.
So it's all about learning from examples.
Yeah, exactly.
So intro.pdf even mentions filtering spam emails as an example of this.
Yeah, it's a great one.
I'm guessing it's like it analyzes a ton of emails that are labeled spam or not spam.
Exactly. Yeah, the algorithm would look for patterns in the data.
Okay.
Like certain words or phrases that are commonly found in spam messages.
And then over time, it gets better and better at it.
Exactly. The more data it sees, the better it gets.
Okay, so how do we know how well it's actually doing, though?
That's where loss functions come in.
Loss function.
Yeah, think of it as like a scoring system.
Okay.
It measures the difference between the algorithm's predicted output and the actual true output.
So if it predicts that an email is spam and it is spam, then the loss function would be very low.
Exactly. Yeah, ideally it would be 0 in that case.
Okay.
Which would indicate a perfect prediction.
But it gets interesting because there are different types of loss functions, right?
Yeah, there's a lot of them.
Intro.pdf mentions logarithmic loss, which has this really interesting property of penalizing overconfidence.
Yeah, that's a cool one.
So, like, if it's really sure but it's wrong, then it gets hit harder.
Precisely. Yeah. It encourages the algorithm to be more cautious and calibrate its predictions better.
Wow, that's really clever.
Which can lead to more reliable results in the long run.
Okay, no, what about, like, noisy labels?
Yeah.
Intro.pdf mentions those as well.
So noisy labels are basically errors in the data, like labels that are incorrect or inconsistent.
So, like, I guess that would introduce uncertainty.
Yeah, it's like trying to teach a kid to recognize animals, but some of the pictures are mislabeled.
Right, it would be hard to learn.
Yeah, it would create a lot of confusion.
So noisy labels, I guess, are just like a big problem.
Yeah, it's a big challenge for sure.
Okay, let's move on to a specific algorithm.
Okay.
K nearest neighbors, or KNN from KNN.pdf.
Oh, yeah, KNN.
It seems like it's all about, like, finding the nearest neighbors.
Yeah, it's a cool algorithm.
To a new data point and then, like, letting them vote on its classification.
It's kind of like a popularity contest, right?
Yeah.
So imagine plotting all your data points on a graph.
Okay.
And to classify a new point, you just look at its K closest neighbors and let them vote on its label.
So if most of them are spam, then the new point is probably also spam.
Exactly. Yeah, it's very intuitive. KNN.pdf actually provides a visual representation of this using what are called Voronoi diagrams.
Okay.
So imagine like dividing the data space into regions.
Okay.
Each region represents like the territory dominated by a specific data point.
It's like a map or something.
Yeah, exactly like a map.
Okay.
Where each region is controlled by a different label.
So, KNNN.pdf also mentions that choosing the right K value is important.
Oh, yeah, that's key.
Like the number of neighbors to consider.
Yeah.
Why is that so important?
Well, if K is too small, the algorithm can be really sensitive to like the quirks of the data. Like it can overfit the data, meaning it does well on the training set,
Okay.
but poorly on new unseen data.
So, like, it's basically memorizing the training data.
Yeah, it's like memorizing instead of generalizing.
But then on the other hand, if K is too large, then
Then it might miss important local patterns
okay.
and underfit the data.
So it's like you got to find that sweet spot.
Yeah, finding the balance is key.
Okay, KNN.pdf uses the breast cancer Wisconsin dataset as an example
Oh, yeah, that's a good one.
to show this trade-off.
It illustrates how different K values can lead to very different accuracies.
Now let's switch gears a little bit and talk about linear predictors from linear.pdf.
Okay, yeah.
I gotta admit, like, hyperplanes always kind of make my head spin a little.
Yeah, they can be a bit tricky.
So, I guess like a hyperplane is just a way to divide data in a multidimensional space.
Yeah, basically, so in 2 dimensions, it's just a line.
Okay.
3 dimensions, it's a plane.
But then like higher dimensions, it just gets hard to visualize.
So yeah, it gets abstract.
So, how does linear.pdf connect these hyperplanes to like classifying data points?
So imagine you're drawing a line on a graph to separate 2 groups of points.
Okay.
A linear predictor does something similar, but in a higher dimensional space.
Okay.
It tries to find a hyperplane that separates the data points belonging to different classes.
So if the points can be neatly separated by a hyperplane,
Yeah.
then a linear predictor should be able to classify them pretty well.
Exactly.
Linear.pdf mentions that minimizing the 0-1 loss is a way to find like the optimal hyperplane.
Yeah, the 0-1 loss is just a way to count MIF classifications.
Okay.
So if a data point is correctly classified, the loss is 0. If it's misclassified, the loss is 1.
So we basically just want to minimize the number of ones.
Exactly. Yeah, you want to minimize the total number of errors.
But finding that optimal hyperplane, though, can be hard.
Yeah, computationally, it's a tough problem.
That's where the perceptron algorithm comes in.
Ah, the perceptron.
Linear.pdf highlights it as like the simple but effective way to find those separating hyperplanes.
Yeah, it's a classic algorithm.
So how does it actually work?
Imagine like a tireless worker that starts with a random hyperplane
Okay.
and keeps adjusting it step by step
Okay.
based on the misclassified data points it encounters.
So like it's just nudging it in the right direction.
Exactly, nudging it until it classifies all the data correctly.
And linear.pdf even mentions a theorem that guarantees this convergence.
Oh yeah, the perceptron convergence theorem.
If the data is linearly separable,
It's a powerful result, for sure.
But what happens if the data isn't perfectly separable?
Oh, yeah, that's where the basic perceptron can struggle.
Okay.
It might oscillate between different hyperplanes, never converging to, like, a satisfactory result.
So what do we do then?
Well, that's where the idea of ensemble methods comes in.
Ensemble methods.
Like calling in reinforcements.
Okay.
Combining multiple classifiers to achieve greater accuracy.
So boosting.pdf talks about that.
Yeah. Boosting.pdf focuses on AdaBoost.
AdaBoost.
It's a popular boosting algorithm.
Okay, so how does AdaBoost create this ensemble of classifier?
It starts with a simple, weak classifier.
Okay.
And then it iteratively adds more classifiers to the ensemble, each time focusing on the data points that were misclassified by the previous classifiers.
So it's like correcting its own mistakes.
Exactly. Yeah. It's like each new classifier is trying to fix the errors of its predecessors.
That's really clever.
And the cool part is AdaBoost assigns weights to the different classifiers.
Okay.
So classifiers that perform well on the hard data points get higher weights, giving them more influence in the final prediction.
So like the ones that are doing good get more responsibility.
Exactly. It's like a team leader recognizing expertise. And this weighting scheme is actually guided by something called a convex upper bound on the 0-1 loss.
Okay.
And these upper bounds, like the exponential function mentioned in boosting.pdf, help steer the algorithm in the right direction.
That makes sense.
Boosting.pdf also mentions other ensemble methods like bagging and random forests,
Okay.
each with its own unique approach to creating and combining classifiers.
Now let's talk about support vector machines, or SVMs.
Okay, SVMs.
SVM.pdf describes them as like finding the dividing line with the widest margin between the classes.
Yeah, it's all about finding the optimal separation.
What does that mean exactly?
Think of it like creating a buffer zone between two groups of data points.
Okay.
SVMs aim to find the hyperplane that maximizes this buffer zone.
So like instead of just any hyperplane, it's looking for the one that creates the most space.
Exactly, creating the most breathing room between the classes.
Okay, SVM.pdf mentions that this can be formulated as a convex optimization problem.
Yeah, that's a key insight.
Convex optimization. I feel like I need a refresher on that.
So think of a bowl with a single, well-defined bottom.
Oh.
Convex optimization problems are like that bowl. They have a single global minimum.
So it's easy to find that optimal solution.
Yeah, exactly.
SVM.pdf even mentions this thing called the Fritz-John optimality condition.
Yeah, that's a bit more mathematical.
Okay.
But it basically helps characterize the solution.
SVM.pdf also talks about slack variables.
Yeah, those are important.
What are those all about?
So slack variables are like safety valves for cases where the data isn't perfectly separable.
Okay.
They allow for a few misclassifications.
So like it's not always black and white.
Yeah, exactly.
So there's some flexibility.
Yeah, exactly.
Now, SVM.pdf also mentions the Pegasus algorithm.
Oh yeah, Pegasus.
What's its role in the SVM world?
It's an efficient algorithm for training SVMs.
Okay.
Think of it as like a finely tuned engine that speeds up the learning process
Okay.
without sacrificing accuracy.
Now, sometimes those linear classifiers just aren't enough. That's where kernels.pdf comes in with the kernel trick.
Ah, the kernel trick.
It sounds like magic.
Yeah, it's a powerful technique.
So can you give me an example of how this kernel trick actually works in practice?
So imagine you have data that can't be separated by a straight line.
Okay.
A kernel function can transform that data into a higher dimensional space
Okay.
where it becomes linearly separable.
So it's like changing our perspective on the data.
Yeah, it's like looking at it through a different lens.
Kernels.pdf gives a bunch of cool examples, like the quadratic kernel.
Yeah, the quadratic kernel lets us learn elliptical decision boundaries instead of just straight lines.
So kernels.pdf also mentions the polynomial and Gaussian kernels.
Yeah.
And the Gaussian kernel is even called universal.
Yeah, it's a very powerful kernel.
What does that even mean?
It means it can approximate any continuous function to arbitrary accuracy.
Okay, so it can basically handle anything.
Yeah, it's very versatile.
Kernels.pdf also points out that kernels can be applied to other algorithms. Oh yeah, like the perceptron.
Like the perceptron.
And ridge regression.
Right.
Making them even more powerful.
So now let's step away from the linear world.
Okay.
And talk about decision trees from treepred.pdf.
Yeah, decision trees.
There's like flow charts that guide us to a decision.
Yeah, imagine a series of questions, each answer leading you down a different path.